Good morning all, welcome to today's session. Good morning, is the voice and audio clear? Audio video, is it clear, sir? Please respond.
Yes, sir.
Yes, sir.
Okay. We'll start the session now.
Good morning.
Good morning, sir.
Good morning to all. Yeah, so today, we are coming to the fourth day of the program. That is the final day. Okay, so many topics are lined for today. So we are continuing from the pressure control valves. So last class, we have seen the pressure control valves. So first we have seen the pressure reducing valve. Okay, now we have also seen the unloading valve. Okay, so one application of the one unloading valve we have seen. Okay, so one application can be the accumulator, can be charged, and once it is charged, the pump can be unloaded to the tank. Okay, it need not work at the full pressure. Okay, the pressure will drop. Okay, full flow will be there, but pressure will be less. So the power will be less. Okay, when say power is equal to pressure into the flow rate, P into Q. This is the power. So pressure reduces, the power also will reduce. So that is how now we are able to reduce the the energy losses. Okay. Yes. So next one more application I am going to show is the high-low circuit. Otherwise, it is also called double pump system. You can see here double pump system. It is also called high-low circuit. Okay, this is one of the typical circuits in hydraulics. So if you are a hydraulic engineer, okay, you are supposed to know what is high-low circuits. Okay, whether you may be using or you may not be using. But that is a one important circuit in hydraulics. So this is a high-low circuit. You can see two pumps. Okay, one is a high flow pump. Okay, maybe 100 LPM, for example. You can take it as a 100 LPM, and one is a small pump. Okay, that is a 2 LPM, 2 or 5 or 10 LPM. Okay, which will give a small flow. Okay, that's why size is small. Okay, but pressure can be different. Okay, the high flow pump, the pressure may be say 20 bar or 30 bar like that. Okay, low pressure. Okay, high flow, low pressure. Okay, second pump is a low flow, high pressure pump. Okay, suppose see when you think of an application, a cylinder is there. Okay, when cylinder you are pushing the cylinder, and after the motion is completed, it has to do some work, maybe clamping or punching or drilling. Some load being applied. Okay, the pressure is required only at the end. The flow is required to move the cylinder from the initial position to the final the operating point. It has to be moved. Okay, so flow is required. So initially flow is required for the movement of the cylinder. Okay, once the cylinder motion is completed, next we start applying the load. A pressure is to be developed. Okay, so high flow is required initially. Okay, high pressure is not required. See, pressure is the development. How the pressure is developed? Pressure is developed due to the opposition to the flow. So while cylinder is moving, whatever the frictional force or something, low opposition will be there. The pressure will not develop. When the job, actual job is being done, that time only the pressure will develop. Initially, pressure will not be there. Initially, what we require is the flow. So the high flow pump is supposed to supply the maximum flow to the system. Okay. Once the cylinder is extended, then the pressure starts building up. When the pressure builds up to a certain level, suppose 100 bar is our aim, maybe at 25 bar pressure is developed, the high flow pump should be unloaded to the tank. Okay. And the low flow pump that will supply the remaining flow, and the high pressure will be developed by that pump, second pump, small pump. Okay, that will develop the pressure. Okay, but the flow is less. So the power, it will be pressure into that pressure into that this much. Okay, the pressure will be developed by the small pump, and it will do the work. To that much force you can get. See, the small pump may be for developed, maybe set for 100 bar. So 100 bar pressure will be there. Okay, so that is the high flow system. So I will show with the simulation. Okay, so whatever it is in the air, we are in the air. So now I will show with the simulation. Come in, no?
Yes.
Just come. So you can see the high-low circuit here. This is high-low circuit. Okay, high flow, low flow, high flow, low flow. Okay, so there is a one pump with a high flow pump. This is a high flow pump with a 106 LPM, and this pressure is maximum pressure. It is rated for 25 bar. Okay, so that is the first pump. Okay, the second pump is here. This is a 2 LPM pump. It will give you only small flow, but it can develop a high pressure. 100 bar pressure it can develop. Okay, so it can supply to the cylinder. So both can supply. So initially you can see both pumps will supply the flow to the system. Okay, so initially you can see the total flow going to the cylinder is 106 plus 2. 108 LPM will be going into the cylinder. Both will work. The check valve will open. Okay, when I operate here. Simulate. So I made a 1:100 simulation speed. 1:100. That's why it is a little slow. Okay, slow motion it is showing, because now 100 LPM goes, cylinder travels very fast. So to reduce that speed, not to reduce speed, simulation speed, I made it a 1:100. The options simulation, you can see the slow motion factor is 1:100. So now when I operate the 4x3 valve, okay, initially now you can see the both total flow will be going. Okay, after that, okay, the high flow pump will be unloaded. This is unloading valve. This is unloading valve. Okay, we made a static pressure here that is acting on the unloading valve, and the high flow pump will be unloaded. So it is now the pressure will be only 0.04 bar here. It is giving you 105.6 LPM, but it goes to the tank. But pressure is very less. The power output will be less from this pump. Okay, the second pump will supply. The second one pump, say if it is continuously turned hold. Okay, so it will develop 100 bar pressure here. That much pressure, force will be developed according to the area. Pressure into area will be the force. That much force, suppose clamping force you want, high clamping force. So you can get that force. The pressure is developed by the second pump. Okay. So now let us see the much more details about the circuit. So the unloading valve is controlled by this unloading valve, which is set at a pressure of you can see pressure of 23 bar. Okay. So when 23 bar is reached, now while the cylinder is moving, when it is almost reaching to the end position, the pressure start increasing. So that time now when 23 bar is developed, this will be unloaded. The high flow pump will be unloaded. Okay, and the low flow pump will supply to the system. The low flow pump will be supplying to the system. The flow cannot go back into the high flow. See, this flow cannot go to this side because check valve will close. So it can only go to the cylinder. So that we prevented by the check valve. It cannot back flow towards the other pump. So that way this check valve is used. Okay, and also this is required to make a static pressure. Okay, so static pressure is we cannot say exactly the static pressure. This flow is also acting here. Okay, this small pump is also acting here. It's not exactly like a static pressure here, but 100 bar is developed here. That is because of this relief valve. The second relief valve is set at 100 bar. This relief valve, okay, that is set at 100 bar. This unloading valve is set at 23 bar. Okay, so when 23 bar is reached, the high flow pump will be unloaded. So overall, you can see that, okay, there is energy saving here in this circuit. This is required when the very high flow requirement will be there. Initially, large cylinder is there. Initially, no. So we don't want to make the cylinder to move slowly. Okay, your cycle time will increase. So always we are in application. Now we are trying to reduce the cycle time. Okay, suppose 20 seconds if you are able to do one job. Okay, and if you can reduce to 18 seconds, okay, or like that, no, the more production possible. Okay, the cycle time we are always trying to reduce it. So we use a high flow pump to make the cylinder to move fast initially. But when it reaches to the end position, flow is not required. Already it has moved. Now we require the pressure. So that time the high flow pump will be unloaded, and a low flow pump will give a small flow only may be required, if at all required. But a high pressure should be developed. So this is rated for high pressure. This second pump is rated for high pressure. So that will develop high pressure, and the required the force will be developed. So this is the idea of this high-low circuit. So we are using an unloading valve here. Okay. So one application of unloading valve is here. Okay, in the high-low circuit. So you may find it in many places. This high-low circuit is a standard circuit. Okay. So that is that you can find at many places. Okay. Manufacturers are providing the pump combinations. Okay, they offer the pump combinations. So you can select what type of flow, first pump what flow, second pump what flow, what pressure, all we can select, and you can combination can be selected. In one shaft, drive shaft, it will be connected. Okay, so one drive, both will be rotated. Okay, so this type of circuits are available. Excuse me, that stop share has to come now. Okay, now we are coming back to the earlier circuit. Okay, so the applications of unloading valve you can see here. This is what we have seen the last day. So this circuit we already simulated. Okay, and this is the one double pump system now. So which you can see that two pump system. Okay, so this is a thing now which is available as a unit. Two pump as a unit it is available. You can see the shaft in common shaft it is both are coupled. Okay, and the prime mover will be connected afterwards. Okay, so this type of things are available, and this is also one unit available. This is an unloading valve. Okay, with a check valve. Okay, only connection maybe you have to make from here to here, and this connection you have to make. This connection you have to make here to the second relief valve. Okay, this is a low pump. Okay, low flow pump pressure is set by this relief valve. Okay, high flow pump pressure will be set by the unloading valve. I think overall you understand the circuit. This from some manufacturers, site I have taken. Okay, they are supplying this type of components. Okay. Okay, now we move on to the next one. Next is a sequence valve. Okay. So many times, in the applications, we require sequence of operations. Suppose two cylinders are there or three cylinders are there. Okay. So one cylinder move first, then after that the second cylinder will move forward. Okay. Then the third cylinder will move forward. Okay. Then the second will return back. Then the third will return back. Then the first will return back. Some kind of sequential operation required in many applications. Okay. For example, now if you have two cylinders, suppose cylinder A and cylinder B. Okay. First cylinder A moves forward. Normally we say A plus. Cylinder A moves forward means A plus. Then cylinder B moves forward. That is a cylinder that is B plus. A plus, B plus. Then cylinder B returns back. Returns back means we say minus. So B cylinder returns back means B minus. Okay. Then we say A returns back. A minus. Okay. So normally this is called notational form. Okay. So we express in terms of notations. Okay. The sequence of operations. Suppose we need a sequence of operation A plus, B minus, A minus. That means A cylinder moves forward, then B cylinder moves forward, then B returns back, then A returns back. So the sequence of operation will be A plus, B minus, A minus. Okay. For example, now you are going to push a job and clamp. Push the job and clamp the job. A plus. A cylinder will move forward means push the job and it will stop the job and it will clamp. A plus. Then there is some drilling cylinder or a punching. Okay. So punching operation. So one B cylinder will move forward and punch. Okay. There is a B plus. Then A cannot return back. Okay. Because B has to return back. So next B will return back. After that, A will return back. So in this type of applications, we require A plus, B plus, then B minus, then A minus. Okay. So many sequences possible. Say you can have A plus, A minus, B plus, B minus, A plus, B minus, again B plus, B minus, then A minus. So various sequences are possible. That depends upon the application requirement. So let us take one particular example. That is A plus, B minus, A minus. Okay. So that we want sequence of operation required. Okay. So you can see this cylinder A. Okay. Cylinder A has to move forward. After that, cylinder B has to move forward. B has to move forward. A will be in the extended position. It is maybe clamping the job. It has to clamp the job. Then B extends and it carries out some work operation on the job. So B plus. After that, B returns back. Then A returns back. Okay. So in hydraulic circuits, we use this sequence valve. Okay. There is a sequence valve available. Okay. The sequence valve is just like your pressure relief valve. Okay. You have already seen pressure relief valve. Okay. Similar to that only it is construction or it's working also similar to that. But in the pressure relief valve, we relieve the pressure or the flow to the tank. Pump will push the oil to the tank through the relief valve. The oil goes back to the tank. Then it is a relief valve. Okay. But the flow is going into the cylinder. So we direct the flow towards the cylinder. Okay. Not to the tank. That means we are using this flow for some control application. Okay. To move the cylinder B. See, the flow is there. The cylinder B can move. But the flow can start only when the sufficient pressure is developed. This is normally closed type of valve. When it is opened only, it can flow. So when you set the pressure, suppose the system pressure is 100 bar. You set for 100 bar. Okay. So initially when the flow is started, straight away the flow go to the cylinder A. Okay. While moving, the pressure will not develop. Okay. 100 bar will not develop. Maybe some 10 bar will be there while moving. So while moving, pressure will not develop. Okay. When the pressure will develop, when the motion is completed. When A moves forward completely, then the pressure starts building up. Okay. When the pressure starts building up, the same pressure is acting on the sequence valve. Okay. When the sufficient pressure is developed, the sequence valve will open. Okay. Then the flow will be directed to the cylinder B. Then the cylinder B will start moving forward. Okay. So only after A moves completely, then only B starts moving forward. You get a B plus action. Okay. So we are able to get A plus and B plus action in the circuit. Okay. I have not shown direction control valve here. Okay. That will, in the simulation software, will add a direction control valve. Then we can control the forward and return side also. Okay. So this is only showing only the forward direction. Okay. A plus and B plus. Okay. So A plus is directly connected. So A plus you can get immediately. Okay. As soon as the valve is shifted, A plus action you can get. But B plus action will not be there until A completes the motion. When A completes the motion, pressure start building up. It acts on the puppet and it will open. At that time, this will be this sequence valve will open, and the flow will go towards the cylinder B. Okay, then B start moving forward. So we are using a sequence valve here. Okay, you can also see one check valve. What is the purpose of this check valve? So whenever B wants to return back, that time this valve will be closed. Sequence valve will be closed. Okay, the pressure will not be there. We are shifting the valve, and the pressure will go down in this. So this will be closed. So oil has to return back. So there is no way through the sequence. Okay, in this pressure control valve, there is no way. So we need to create an alternative path. For that, a check valve is provided here. So when the B is returning back, the check valve will open. Okay, if this check valve is not there, it will not return back. It will not be able to return back. So because this check valve, it will return back. The flow will go to the tank. Okay, it is able to return back. So usually in a sequence valve, there will be an integrated, or if it is not there, parallelly you have to connect a check valve. Otherwise, it won't work. So this is a sequence valve. In relief valve, it is not required. In relief valve, check valve is not required because anyway the flow is going back into the tank. Okay. In relief valve, the flow is going into the tank. So the check valve is not required there. So here it is required. It will come back. It will go into the cylinder also. That oil has to return back. So we have to create a path. Return path we have to provide. That's why this check valve is required. So usually it may be integrated check valve. When a sequence valve is there, inbuilt, integrated check valve will be there. So that will take care. So that is how it is done. So we'll see the circuit. Okay, this circuit we are going to see through the simulation software. So the pump is there. There is a 4x3 or 4x2 valve you can use. So in this left envelope, it will go for the forward motion. Okay, A plus. Then see A plus will be coming immediately. A plus will come, and that pressure develops. Then B plus also will come. B moves forward. Okay. When you shift the valve to the right hand envelope, then the flow will go this side. Then immediately B starts returning back. Okay. After B completes the motion, then this sequence valve will open, and then A will start returning back. So you are getting A plus, then B plus, then B minus, and then A minus. So I have to use two sequence valve. Sequence valve 1 and sequence valve 2. Two sequence valves are used. We'll see in the simulation software. It's coming now. Okay. So you can see the sequence valve connected. Okay, there is also 3-cylinder system also there, a 2-cylinder system also there. First, we will see the 2-cylinder system here. Okay, A plus, B minus, A minus. So here, the pump is running and it is relieving through this one. Pressure of 50 bar, it is developing here. Okay, so when I operate this valve, okay, the cylinder A is moving. You can see the cylinder A is moving. The pressure is only 0.72 bar. Because while A is moving, okay, the opposition is less. Okay, the flow opposition is less. So when it completes the motion, the pressure will develop here in this line. In this line, the pressure will develop here also. So then only it will act on this one. Okay, that time it will open. You can see also the check valve getting opened here. For this oil to return back, this check valve is getting opened. It is going to the tank. Going to the tank. Otherwise, it is difficult. If it is not there, it cannot return back. Because slow motion made, I put some 1:100 slow motion. That's why it is moving slowly. So now cylinder A is almost reached to the end position. You can see the pressure start developing. When the motion stops, the pressure builds up. See, pressure builds up. Okay. When that pressure is reached, so now the flow is going, it should go to the cylinder B. See, now the flow starts going to cylinder B. So after A plus, now you get B plus also. So through the sequence valve, the flow is going into cylinder B. We start moving forward. So now the simulation speed, I'm not able to change now. One is 100 I made.
That's right. Okay, no problem.
So this is B plus. So B plus is complete. So maybe some punching operation, something like that. Okay. Now you have to bring it back. So now you press from this side. So B is returning back. Straight away the oil go into the B this side. Then A start returning back. So real time it will be like this. The main maintain real time. The real time it will be like this. A plus, B plus. Next B minus, A minus. Not only 2 cylinders, even 3 cylinders also you can use. We want some particular sequence. That is also possible. Suppose you get A plus, B plus, C plus. Return will be, okay, C minus, A minus, B minus. Okay, so you have to arrange the pressure setting properly. Okay, you have to set the pressures properly. You can get any sequence you want, you can get it. See, normally in pneumatics we use sensors and automatic operation you can get. Okay, but there is no pure hydraulic system like what we do in pneumatics. That the pneumatic control system now we have the separate elaborate control system possible with the pneumatics. We can keep sensors, okay, to sense the positions of the cylinder. That type of things are not possible in hydraulics. Okay, that is possible only with electrohydraulics, not with the pure hydraulics. Okay, without any electro, it is not possible. Electrohydraulic, electro-pneumatic, both are same. So the similar way we can get sequential operation. Okay, but sometimes we are using pure hydraulic system. Okay, there is no electro. Okay, probably in Ongc also some applications we may not use electrical. Okay, because to avoid spark and all, you will use a pure pneumatic system or a pure hydraulic system. So this type of valve may be used. Okay, the sequence valve. Okay, basically it is like a relief valve only. Okay, but application where it is applied, say relief valve here. Okay, this is applied to relieve the pressure. Okay, relieve the flow or pressure, or to prevent the over pressurization of the system. Particular pressure is reached, it will open, the flow will be going to the tank. So it will go to the tank. That is the difference. Here it will go to the system for control application. Here it is to modulate the power. So the application is different. Okay. So when the oil is going back to the tank, same way it will not come back. So check valve is not required. Okay. It will come back only through pump only. So here check valve is not required. So one way you can find out whether it is a sequence valve or a relief valve by seeing the check valve. If a check valve is there, it may be either a sequence valve or it may be a counterbalance valve. Okay. The possibility is like that. If you see a check valve. Okay, it is not for modulating the power. Okay, if you see like this, okay, unloading valve also like this only, similar to this. It will go to the tank. The flow will go to the tank. Here it is going into the system for further control application. Then the same valve is called a sequence valve. Okay, internal construction will be maybe same. Okay, the internal construction of this valve and this valve will be same. But where it is applied, it is different. Accordingly, it is called a sequence valve. In this type of application, it is called a sequence valve. I hope you understood this one. Okay, the sequence control of cylinders, sequence valves are used. Next, a very important one valve is the counterbalance valve. This is a counterbalance valve. Okay, so what you are counterbalancing? Okay, so in the hydraulic application, you can have different types of loads. One is a positive load. Okay, positive load is when the cylinder is when cylinder is opposing and moving forward. The cylinder motion is opposed by the load. Okay, cylinder moves. Suppose cylinder moves forward. Okay, it is permanently attached with a heavy load. Okay, for something heavy thing it is pushing. Okay, that load will oppose that motion. Such a load is called a positive load. Okay, there is a positive load. Okay, whereas some applications you can see like a heavy load is brought down under gravity. Okay. Suppose a crane now bringing a heavy load downward. Okay. So hydraulically, you prefer that load should come down hydraulically. When you apply a hydraulic force, by that force it should come down. That is what we generally require. But because there is a heavy load, the load will pull it down under gravity. Okay. There is a possibility that the load will be running away. Okay. There may be some dangerous situation taking place. So we have to bring the load in a controlled manner. Okay. Or the load is coming down or it is running away. We have to opposing force we have to give. Counterbalancing. We have to counterbalance that that movement. Okay. Then in a controlled way, we can bring the load down. Okay. One way to give a counterbalance is to provide a, probably Madam would have taken about pilot operated check valve. Taken now. So load holding circuit. There is one typical circuit called load holding
check
circuit.
Valve pilot operated not taken. Only check valve.
Check valve. Okay. 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 There is a also one more method. That is not a very sophisticated method, very crude method. Okay, generally it is not used, but it is also a method available for a simple applications and all. We can use a pilot operated check valve to hold that job. Okay, and bring that load in a controlled manner. Okay, but a very sophisticated or a very most commonly used method is by using a counterbalance valve. Okay, anyway, I will show both methods or 2-3 methods how to bring a load, heavy load downward in a controlled manner. Okay, so there are some 2-3 methods are available. So we can see that. Okay, when we can compare the methods, which is the best method. Okay, so this is a counterbalance valve, which will oppose that the oil returning back from the cylinder. This oil, say this A is connected to the load point, the cylinder. This is connected to the cylinder. Suppose load is coming down. Okay, one side, oil will be coming to the tank. It's going to the tank. Okay, so we keep a counterbalance valve there. Okay, that pressure has to be set. Proper pressure has to be set. Suppose now you set the main pressure relief valve for 100 bar. Okay, and this counterbalance valve you set for say little above 105 bar. Okay, so when 105 bar pressure is developed here, this force will act. This pressure will act on the puppet. It will open. This counterbalance valve will open. Allow that oil, trapped oil, to go to the tank. B means it is ultimately connecting to the tank. Okay, so straight away it cannot go to the tank because the valve is closed. But pressure develops. Okay, little higher pressure. Okay, so when 105 bar is developed, it will open and then it will start relieving the pressure. Okay, when the pressure is being relieved, again pressure drops. Suppose in a slow motion when you take, maybe it is become 95 bar. Okay, then again valve will be closed. Okay, the flow is not able to go to the tank. It is again blocked. It is trapped. Okay, but the load will push. Bring it. It will act on this trapped pressure. Again, the pressure will increase. Okay, so the pressure goes to again 105. Again, this will open, and again A to B flow is possible, and the flow go to the tank. Okay, till the load is coming down to the extreme downward, it will go like that. It will open, it will close, it will open, it will close. Okay, dynamically it is sensing the pressure here. Dynamically sensing the pressure. It opens here. Okay, opens and closes this valve, and a little bit oil will be relieved. Then again closes. Again the load has to it will be opposed, and it will stop. In a controlled way, we are able to bring the load by the action of this valve. See, generally, okay, when there is a flow is there, okay, there is a kinetic energy. When flow is there, there is a kinetic energy. Okay, suddenly when you stop, what will happen? A kinetic energy, suddenly you cut. Suddenly when you stop, there will be high back pressure. Okay, so that is what is happening in the in a pilot operated check valve. There is a pilot operated check valve. We can manually control that pilot opening. Okay, so there is a orifice opening is there, and there is a puppet will be there. So it can be opened or closed. So suddenly you are cutting the flow in the pilot operated check valve. Whereas here it is not suddenly you are not cutting. Okay, you are in a orifice. It is the spool is moving axially. Not at a time it is closing opening. Okay, we'll see that here also in the cross section. Okay, there is a counterbalance valve. Okay, so A to B is the connection. Okay, so A to B flow will be so B to A will be through check valve. So B to A will be through check valve open. B to A flow is easily possible. This is a check valve. Okay, so B to A flow is easily going. This will push and the flow will be going to A easily and going into the cylinder. But when load is brought down, that oil from A should go to the tank. So check valve will be closed. So it has to go through here. Okay, this should be opened. So that pilot line is acting here. Okay, when it is slightly pushed, what will happen? A small, say 1 mm, it is opened. So one flow is possible here. Okay, not a complete flow. Okay, some flow is possible. Okay, when the pressure drops, it will come back. Okay, so it is dynamically sensing the pressure and opening and closing here. Okay, in contrast to the pilot operated check valve, this valve is not at that time, it is not closing. Slowly it is closing. Little slowness is there. Okay, here in the case, because this is a spool is moving axially across the orifice. It is not cutting suddenly. At that time, it is not cutting. Okay, so this is how it is working. So in the counterbalance valve, it can dynamically sense the pressure, and it will be closing, opening is done here. Here, some little opening, closing, it is done here. It controls the flow from A to B in a dynamic manner. That is the difference. Okay, so sudden cutting of pressure is or a flow is not there. So there will not be any that much back pressure will not be there in this case. That is the main difference.
Flow will go from B to A as it is closed.
Which way is going through the check valve? See, this way, no? Some opening will be there. This will be push this one, and B to A will be flow is a easy flow.
Okay, sir. Okay.
That will go into the cylinder.
Okay,
That's what this check valve. Okay, this check valve will open and it will go to the A. And cylinder, going upward. So hydraulically, it is going upward. Okay, there is no gravity. Gravity is pulling it down. Okay, but hydraulically, you are against that. Both forces are opposing. Hydraulic force is opposing the downward force. Whereas when it is coming down, when load is coming down, hydraulic also in the same direction, gravity also in the same direction. Both will make the load to run away. Okay, so this is whenever the load vertically mounted cylinders and all, load in one direction will be okay, but opposite direction now coming down always it is a problem. So we have to control that movement of the load. So there we can use this type of counterbalance valve. Understood this construction, the operation of the valve. We'll see the circuit simulation. Then much more clearly we'll understand there. So here all the types are there. Okay, this is the pilot operated check valve. This is a pilot operated check valve. Okay, it is sensing the pressure. The check valve. Now that part you can understand, I think. Okay, this is a pilot line is there. Okay, so the valve, the flow from B to A is always possible. Okay, but the flow from B to A flow generally not possible. But if you give a pilot signal, B to A flow also possible. So that pressure is coming from the other line. See, this line pressure is developed only. The return oil can go to the tank. Okay, this side pressure should develop. If it is running away, if the cylinder is running away, the pressure will drop. So at that time, check valve will be closed, and the flow going into the
Sir, we are seeing the same presentation.
Same presentation. Okay, 1 minute. Sorry.
Yes.
Okay, so you can see 3 circuits. So this for comparison purpose I made. Okay, so say the cylinder now it is bringing the load down. Okay, when downward motion is there, here this check valve is there, check valve will block the flow. Okay, but this can be opened. B2A flow can be opened if this pressure is developed. This side pressure is other line pressure is developed. Okay, so then only it will allow this oil to go to the tank. Okay, till that time the load will be opposed by this one. Okay, it will trap the oil here. It will not allow the cylinder to come down, move down. Okay, when the hydraulically pressure is developed here, then this check valve will open and the flow is possible to the tank. That time the load will come down. But since you are suddenly closing this, there will be some back pressure developed here, shock pressures developed here. Okay, that pressure will be more than that pressure in the other side. So it will lift it up a little bit. Then again it will come down. That means there will be jerkiness of motion. Okay, when you are using a pilot operated check valve, the problem is the load will jerk. When you are stopping now, suddenly it will jerk there. It will move up and down a little bit. Okay, because the pressure changes. The pressure, back pressure, shock pressure will be developed. Okay, then it is pushing it up. Then the pressure drops. Then that side pressure will be getting more. Then that will push it down again. So that way, some jerkiness will be there in the pilot operated check valve. Whereas in the counterbalance valve, okay, I connected this also. This I will remove. Only counterbalance valve I connected here. Okay, so the system pressure is, you can see the system pressure is 50 bar. 50 bar system pressure I developed. Here I set the counterbalance pressure is 52 bar, little above. Okay, so that may be a little bit problem. What pressure it should be set. It should not set high pressure. Okay, so it is capable of developing. Suppose 50 is there, even 100 or 120 bar also may be developed here. Even though your relief valve is 50 bar, here very high pressure may be developed in this line. Because suddenly, the load, depending upon the load, suppose heavy load, 100 kg load, that 100 kg will be acting on the oil here. Okay, that much pressure will be developed. But we don't want the very high pressure because your components are all rated for some particular pressure. If more pressure is there, it may get damaged. So, say 50 means 52, little 10% more pressure can be set. So, here pressure will not go more than 52 bar. When 52 bar is developed, it will open and release the oil. Okay, it will go to the tank. So that way it will safeguard. Okay, it should not be set for very high pressure. I will show that how much pressure can be developed in this part. Okay, so shall we simulate? So third circuit is for. Okay, you can also do the same thing with a 4x3 valve center position closed. So the operator is seeing and he is operating the valve, okay, bringing the load down. Suppose it is running away, he will bring the valve to the center position. Then everything will be blocked. And this check valve, okay, is a throttled valve. Okay, that will not allow the flow to go to the tank. Okay, so this type of circuit also can be developed. You can use. Okay, but it is not generally used. This type of circuit is not generally used because this is we cannot predict. Okay, there will be very high pressure development and you cannot get a good result in this method. Okay, so that is not used, but I have shown as a method. Okay, it is also a method, but generally not used. But what we have to learn is when you are using a throttle valve, okay, to restrict the flow, okay, there may be a very high pressure development in one side. In this side, there may be very high pressure development. So that is called pressure intensification. There will be pressure intensification on this side, on this part of the circuit. Okay. To release that pressure, you can have a separate relief valve. Separate relief valve can be used. This relief valve is not for setting the pressure. Say this may be set for how much? 50 bar. Okay, so this is set for 52 bar. Okay, suppose you set for a very high, say this, if you set for 100 bar, even 100 bar may be developed in this part. In this line, even 100 bar may be developed. Okay, because this is not allowing the oil to flow to the tank easily. If you restrict too much, suppose the restriction is only 2% opening you made. Okay, so let us see. So if you operate this one, so you will get see 100 bar. A little bit slow motion if you make 1:10. So the load going up is hydraulically going up. Okay, now if I bring it down, so what will be the pressure developed in this line? You say 82, 77, 80 bar pressure will be developed. Whereas your system pressure you set for only 50 bar. So this is the pressure intensification. So when you are using a throttle valve, there is always a chance of pressure intensification in one side. In restricted path, there is a chance of pressure intensification. If you don't want to increase the pressure, you can relieve that pressure through a relief valve. So here 80 bar is developed. Here you set for 50 bar. So around maybe it should not be less than that. Okay, it should be little 52 bar or 55 bar. Okay, little above your set pressure here. Okay, then the pressure will not go more than that much. So 52 is the pressure developed in that line. It is a safe pressure now. So this is, so sometimes in hydraulic circuit, you may find a relief valve connected like this. So the purpose you must understand. It is not for regulating the pressure. Okay. It is to safeguard against the pressure intensification. Whenever restricted lines, wherever restricted lines are there in hydraulic circuit, okay, the pressure, there is a chance that pressure may go very high, even double or triple pressure may be developed. Okay, we want to know. Otherwise, this high pressure developed, the hose may burst. Okay, or somewhere weak points, it may it will break and the oil will come out through that. To safeguard, we may connect a pressure relief valve. We should not think that that is for setting the pressure. That is not for setting the pressure. Okay, that is to safeguard that particular line. Okay, so now that is set. Now we'll see the counterbalancing. Okay, the counterbalancing. Okay, I operate this one. Okay, so it is coming down. We bringing the load down. The maximum pressure developed is 52 bar because I set for 52 bar here. If I set 55 bar, that much pressure will be developed. Okay, suppose if I set for 55 bar, 55 if I set, so maximum 55 bar will be developed. Maximum 55 bar will be developed. So dynamically it is bringing, it is opening, closing, it is being taking place here. Okay, so it is bringing the load down with a counterbalancing of 55 bar. Okay, it is counterbalancing. That 55 bar will be the counterbalance pressure for the load. Okay, so in a controlled way we can bring the load. This is a pilot upper check valve. Okay, that also bring the load down. See, whatever you see here now, the pink color, this is like a vacuum. And you see the jerkiness here. So it is bringing the load with a jerkiness. So all three are doing the same work. Okay. So going up is okay, no problem. That is through the check valve opens and it goes. So all the three we are operating simultaneously. Okay. Now we are operating all the three simultaneously. We can compare the methods. Okay. Which is the best method we can find out. See, counterbalance, you see, there is no jerkiness. Okay. Whereas pilot upper check valve, the load is being brought down with a jerkiness. Okay. So there are three methods I have shown here. Okay. So the best method is by using a counterbalance valve. So that is what is the maximum used. in your Ongc application also you see this type of application. When you are bringing a load down, this type of counterbalancing will be done. Okay, rather than the pallet operated check valve, or this is a very very simple method. Okay, that may not be used much. Okay, or maybe sometimes you may find all the three used in one circuit. Counterbalance used, pallet operated valve is used, and a throttle relief valve in a meter out method. It is always connected for meter out method. In this application, when you are bringing the load down, meter out method is connected. Throttle load check valve is connected for meter out method. But you are restricting the flow down. Okay, there is a pressure intensification. Maybe like this throttle relief valve also will be connected. Okay, so this is a counterbalancing. It is also like relief valve only. As a construction is concerned, like a relief valve or a sequence valve. Okay, the inlet pressure is sensed, so it is like a sequence valve. But this is used for this type of application. It is used for the counterbalancing the load. It is used for counterbalancing the load. That's why this is called a counterbalancing valve. Same valve if you connect for sequencing application, a cylinder and the flow going into the cylinder, then that valve can be called as a sequence valve. You can use the same valve for sequencing application also. Okay. But since I am using for this application, this valve is called the counterbalance valve. Okay. So these are all pressure control valves. We are sensing the pressure and some kind of control we are getting. Okay, sensing the pressure, load pressure. Okay, the load bringing down now. Load pressure will be developed here. That pressure is sensed, and this valve is operating dynamically, dynamically controlling the opening closing of the valve. Okay, now actually, the spool is moving actually, and not a sudden closing or sudden opening, as in the case of a check valve, say pallet operated check valve. So there is orifice is suddenly opened, suddenly closed, fully opened. So that type of operation is taking place here. Okay, that's why the jerkiness will be there in this case. Here there is no jerkiness. Okay, in the case of a counterbalance valve. Okay, so I think so many concepts you got in this application. Okay, so many counterbalancing. Okay, what is counterbalancing? The load has to be counterbalanced. Load coming down has to be counterbalanced. So this type of thing you can use. Sometimes when even vehicles, suppose hydraulically operated vehicles, when it is going downward, okay, suppose a slope downward, okay, then also this counterbalancing can be done. Okay, this counterbalancing can be done, or unloading valve. You can use like unloading valve, that type of thing, that also can be used. But I have not taken much for you because probably you may not be using any mobile type of application. Okay, so that is also available. Braking, so braking the downward motion. Okay, so such applications also used, this type of pressure controls. So these are all about pressure control valves. So we have seen the pressure reducing valve. Okay, this is pressure reducing valve is used to get different pressures in the same pump circuit. One pump circuit in different parts, you must get different pressures. Generally, one pump is there, one relief valve is there. Throughout everywhere, now you have the same pressure. But I want to have different pressures. Then I can use a pressure reducing valve. The downstream of that pressure reducing valve, you can have a reduced pressure. Okay, so that application, I have seen some of the Ongc circuit also. It is used. It is being used. You can see when you go back, you can see the pressure reducing valves are used. 2-3 pressure reducing valves are used. So one may be 200 bar circuit, one may be 100 bar circuit, one may be 50 bar circuit. So 2 reducing valve we can use. Okay, 1 relief valve we can use. You can get 3 different pressures in the circuit. So pressure reducing valve. We have seen the unloading valve. Okay, we want to unload the pump. We want to unload when some particular operation is complete, like charging of an accumulator. When charging of accumulator is complete, the circuit should be unloaded. The pump should be unloaded to the tank. Okay, the check valve will close. The pump will unnecessarily should not create a high pressure and operate now pushing the oil to the tank through the main relief valve. Okay, it has to do more work because the pressure setting will be higher. Okay, say a 10 lpm to 300 bar. So continuously it works like that. Energy loss will be there. If it is through unloading valve, like a tandem sender valve, you must be aware. Even tandem sender also, if you bring the valve to the sender position, okay, then the unloading will take place. But we have to bring the valve to the sender position. But here it will automatically sense from the some static point in the system, and automatically it will unload. Okay, so you can use an unloading valve. Then we have seen the sequence valve, sequencing application. You can use sequencing valve. Okay, and 2-3 cylinders are there. One after another cylinder has to move. So sequencing in a sequential manner, it has to move. We can use a sequence valve or sequence valves you can use to get the sequential application operations. Then the counterbalancing also we have seen. Okay, these are all about the pressure control valves. Yeah, now we'll break for some 5 minutes or 10 minutes. Okay, after that I will talk about accumulators, hydraulic accumulators. Okay, so construction and some circuit we'll see hydraulic accumulators. Okay, so we'll break for some time. Yeah, welcome back. So just now we have seen the pressure control valves. Okay, so the next topic is hydraulic accumulators. Okay, so many applications now we have to store energy. Okay, there is one requirement. Okay, maybe sometimes we have to suppress the shocks or pulsations in the circuit, or sometimes we have to compensate some leakages and all. Okay, so there are various requirements like that in hydraulic applications. Okay, so such applications, we are going to use hydraulic accumulators. So there is a class of devices called hydraulic accumulators in hydraulic system. Okay, where we can store the energy. So generally, we cannot store because oil is incompressible. Hydraulic oil is incompressible. We cannot compress and store the energy in hydraulic system. Okay, there is no way to store energy. Okay, we can use some other media like air or not air, some gas or spring or a heavy load, heavy weight. Okay, that we can lift. When high pressure is there, we can lift that load. When pressure drops, that load will push back that oil and can be supplied to the system. Or a spring can be compressed. Okay, when the spring expands, energy can be retrieved. So that type of mechanism we have to make. Okay, for that now we have got accumulators. So we'll see the construction types and construction. So this is different types of accumulators. Okay, this is a bladder type accumulator. This is a diaphragm type accumulator. Okay, so various things are there. So we are going to see this type of things, other associated components. Okay, now we'll see very fundamental idea. We are trying to get the fundamental idea of accumulator. Okay, so there is a pump here. Okay, pushing the oil into the system. The cylinder, suppose cylinder is moving forward. That time suddenly when you close the valve, that kinetic energy, the flow, kinetic energy, you are suddenly stopping. Okay, so how fast you close the valve? Okay, that much effect, effect will be there for the upstream side. Okay, there will be high shock, shock pressures will be developed in the upstream side of the system. The flow is there. Okay, so shock pressure will be developed. So the shock waves will travel. See, back and forth, shock waves will be traveling. Okay, it will act on all places, in those part of the circuit. So wherever is there any weak point, some seal, some seal, light seal is there, it may leak. More leakage will be there. It may affect those components. So the shock pressure will be there in the hydraulic system. Okay, how to compensate this shock? How to suppress this shock? Okay, for that now we can connect an accumulator. The same system. Okay, now we connected an accumulator. Okay, there is a gas. Okay, suppose this is a gas charged accumulator. Okay, and then one side is hydraulic pressure. Okay, you are connecting to the one side, connecting to the hydraulic side. Other side you have got the gas. Okay, usually nitrogen gas is used in hydraulic accumulator. Pure nitrogen gas is used. Okay, that can be compressed or that can be expanded. Okay, depending upon the pressure in the hydraulic side. So now when you suddenly close the valve, any shock pressure comes, it will act on the diaphragm or the bag. Okay, suppose a diaphragm accumulator or a bag accumulator or a piston accumulator. Okay, it acts on the that medium, that is the barrier. Okay, and that will compress the gas here. Okay, the shock can be absorbed by the accumulator. Okay, so that way, the effect of shock can be reduced. Okay, very smooth operation. The shock is absorbed by the accumulator. Okay, this way we can suppress the shocks or even pulsations. See, the pumping action is in a pulsed way. Okay, pumping action is taking place in a pulsed way. Say one pulse of oil is pushed into the system, then next pulse, little bit pulsation is there. That also we can smoothen out. Okay, so we can use an accumulator. So this is the very basic idea we are getting about the accumulator. Okay, pulsation dampening. Okay. Okay. Now another application of hydraulic accumulator is to store energy. We can also store the energy in the using an accumulator. Okay. Suppose some whenever excess pressure is there, that time we can store the energy. Okay. Sometimes some period of time, high flow required in the system. Okay. So at that time, the pump flow will be complemented by the accumulator flow also. Both will combine, will supply energy to your system. Okay. Suppose there are some 2-3 cylinders are there. 2 cylinders are small cylinders. 1 cylinder is a very large cylinder. In another words, say 2 cylinders are taking say 1 LPM, 1 LPM each. Okay. When large operation is required, that cylinder is taking 10 LPM. Okay. So generally, when you design the system, you have to design for the large flow. So pump should be sized for 10 LPM, not for 1 LPM. Okay. So large sizing is required. Large pump we have to use. Okay. Sometimes we can reduce the size of the pump by using an accumulator. Okay. You can make the pump to supply an average load. Okay. When average loading, you can supply. Okay. Remaining part of the flow will be supplied by the accumulator. So you can reduce the size of the pump. For example, you can see here. So here some 1, 2, 3, 4, 5 cylinders are used. So first cylinder, okay, maybe 10% of the time or 20% of the time this will supply. Then the second cylinder will supply. Okay, maybe say 8 LPM. This is 7 LPM. This is 6 LPM. This is 12 LPM. Okay, this is one large cylinder that requires 20 LPM. Okay, so 20% of the time it requires only the large flow. Remaining all time now you require a very less flow rate. Okay, so when you design the system, hydraulic, the pump should be designed for the 20 LPM. Okay, the pump must be able to supply 20 LPM all the time if an accumulator is not there. Okay, so that can be reduced, that situation can be changed. Okay, by having a system like this. Okay, we are using an accumulator here. A pump is designed to supply maybe say 12 LPM, not 20 LPM. Okay, pump will supply 12 LPM. Remaining 8 LPM will be supplied by the accumulator. Okay, so accumulator will be charged during the excess energy is available, excess pressure is available. That time accumulator gets charged. Okay, when this small time period, okay, accumulator has to supply. Okay, along with pump plus accumulator supply will supply the total requirement of the flow. Okay, so that way if you design, okay, you can reduce the size of the pump. Once the size of the pump, size of the flow rate is reduced, all component size also will reduce, including your conductor size. Okay, the tube or a hose, everything size will reduce. Okay, the flow rate is reduced. So that way we can design the system. So this is the energy storage. Okay, accumulator will store the energy and then it will supply whenever the system requires the energy. Okay, more energy required, that time it will supply. So this type of applications we can use the accumulator. Another application will be the leak compensation. See, sometimes we want to have an operation which is carried out for more hours. Okay, say 4 hours or 2 hours. Okay, like that, application. You are some 4 cylinders are pressing something. Okay, some pressed wood. Okay, suppose manufacturing of pressed wood. Okay, that wood should be that should be pressed for more hours. Okay, so normally what we will do, all the 4 cylinders will be extended, proceed the job, and bring the valve to the center position. Okay, or close center position valve. Okay, so say 100 bar or 200 bar, that pressure should be there for all the 4 hours. But there will be leakage, through the center position valve, P to the tank, even though it is closed, there will be some leakage. So the pressure will slowly, gradually, it will reduce. Okay, so that time whenever the leakage is there, that much flow will be compensated by the accumulator. If you connect an accumulator in the system, if you use an accumulator in the system, that accumulator will compensate for any leakage, and the pressure will be maintained throughout that period. Say 4 hours means 4 hours, that the correct pressure you will get for the clamping application. So such applications also we can use a accumulator. So accumulator can be used for many applications. Okay. Say not always. Say all that hydraulic circuit may not be requiring accumulator. You have to see the type of requirement, and then we have to decide whether accumulator has to be used or not. Okay. Across the board, we are not using accumulator always. Okay. So see the application and then use. One more application is the auxiliary power source. Suppose, say when suddenly the electric power supply goes off, okay, the supply turned off, or automatically electric supply goes off, okay, but that job, at least 1-2 cycle, it should work. That much energy can be stored. Is like a pneumatic system. So pneumatic energy stored in a tank, okay, and then even if electric supply goes, it can work for some half an hour or so. It can work, or 10 minutes or half an hour. It can work. Similar to that, in the hydraulic system also, not to that extent to the pneumatic, but 1 cycle or 2 cycle, it should work. Okay, so you can use an accumulator. Okay, large accumulator you have to use, or number of accumulators, 2, 3, 4 accumulators you use. Okay, some 2, 3, 4 cycles operation you can get through that. And at least 1 cycle, job, when it is midway, if the supply goes, it should be completed. The cycle should be completed. At least that much energy you must be able to supply. So that much you can get. So now you can see the accumulator applications. Okay, leakage makeup, standby energy stores, fluid separation, pulsation dampening. Okay, there is energy storage, shock dampening, noise dampening, shock absorption. All those purposes we can use the hydraulic accumulators. See, application areas, various application areas are there. Off-road vehicles, offshore platforms also it is used. Entertainment, these are concerned with Ongc, okay. Aerospace, furnace, steel mills, wind mills. So wind mills also normally hydraulic system is used in the wind mills. So the fans are rotating now. It will rotate the hydraulic pump, okay. The bottom part your electric motor, hydraulic motor will be there. So it will draw the oil and the pumping to the hydraulic motor. It will drive an electric generator. Okay, so that type of system is there in the windmills. But maybe to the shock suppression or something like that, it may be used in the windmills also. So a lot of applications are there. Okay, now we'll see the different types of accumulators. Okay, so whatever blue color, that is the most commonly used type. Okay. There are various other types are also available. These are sometimes it is maybe obsolete or it may not be used nowadays. So accumulators can be weight loaded, spring loaded, or gas charged accumulators. Okay, in that weight loaded or spring loaded is now almost obsolete. Okay, you may find it some places if it is a very old system. Suppose 20 years, 30 years system still you are using. Sometimes weight loader also you may find, or spring loader also you may find. But all the new systems you design with the gas charged accumulators. In that there is a separate type, and gas and oil, there is a separation must be there. Then it is a separated type. If it is no separation, there is a non-separated type. This is an old system. Okay, the gas will be there in the top, bottom part oil will be there. Okay, so gas will be retained there. Okay, so you have to take all the care. The oil should not get relieved. Okay. You have to use a valve and to retain that oil. Then the top part gas can be retained. This is a non-separated type. Because some mistake, something happened, or some gradually the gas will be, it will be mixed with the oil and it will be, some loss will be there. So progressively the gas amount of the volume of oil, gas will be reducing. So that type of problems are there in the case of non-separated type. We are nowadays using the separated type. Between the gas, nitrogen gas, and your hydraulic oil, there should be a separation. You can have a piston separation, or a diaphragm can be used, or a bladder can be used. Okay, that will separate the gas and the oil. So that type only I'm going to concentrate more on this. Okay, these 3 types, and in that these 2 are more common. Okay, and in that one type which is very common is the bladder type. Most of the majority of the accumulators are bladder type. So the symbols, as far as symbols is concerned, this is a no barrier. Gas will be there, the oil will be there. This is a hydraulic port. Okay, other side gas will be there. Okay, so first the gas fill and then hydraulic oil applied, then one shutter valve will be there. So that will maintain that gas there. There is a weight loaded accumulator and there is a weight is there. Okay, so when hydraulic pressure is more, the weight will be lifted. So the energy in the form of potential energy can be stored. Okay, whenever the hydraulic pressure drops, that weight will push it, the oil, whatever oil now, into the system. So that way. Or a shock absorption means it will absorb the shock. Okay, so the purpose is not to store the energy. To suppress, its purpose is to suppress the shock or a pulsation. Okay, so basically two types of application. Either one is a storing the energy, okay, or otherwise it is a suppressing the shock or pulsations. These are generally these two type of applications are there, and their circuits are also accordingly. There are two types. We'll see that later. What is the circuit? So this is a weight loaded accumulator symbol. This is a spring loaded accumulator. Okay, there is a spring will be there. Okay, and, this is a hydraulic side. Okay, most commonly used accumulator is this type. Okay, this is a gas. A gas can be used. Okay, mostly the nitrogen gas is used. You should not use oxygen or normal air should not be used. Okay, there is a risk of explosion. Okay, so that's why nitrogen gas is used here. Okay, and it will be pre-charged. Your accumulator will be pre-charged with the nitrogen gas to certain pressure, and then hydraulic pressure can be applied. So the gas loaded accumulator symbol. So weight loaded, you can see the weight loaded accumulator. Okay, so this is the piston. One piston will be there, and the same piston will be extended, and a number of weights will be used. Okay, okay. Whenever this hydraulic side, okay, hydraulic port is here. This will be connected to the hydraulic side. So when high pressure is coming, it will lift the load. Okay, so when the pressure drops, the weight that will exert pressure on the gas here, the oil here, and the oil will be pushed into the hydraulic system. That one, the spring loaded. Okay, so instead of weight, there is a spring is there. The spring can be compressed when high pressure is there. When pressure drops, the spring will expand, and then that oil can be pushed into the hydraulic system. Okay, this I am not very much seriously taking this one. Okay, we are going into the gas charge type of accumulators. So the construction you can see here, there will be this is a piston side, piston type. There is a piston here. Okay, so one side you have the fluid chamber, hydraulic side. Okay, and other side you have got the gas chamber. Nitrogen gas has to be filled up to the required pressure. Okay, to the pre-charge pressure. So for that there is an opening here. Okay. So this can be opened and it can be connected to the nitrogen cylinder, and charge kit will be there. You can charge to the required pressure. We have to first decide what is the pre-charging pressure. To that pressure, you can charge the gas here. Okay. After that, you will close here, and it will be tightly closed. Okay. It will be retained here. Many years it will be retained. Okay. So there should not be any leakages at all. Okay. For that pressure. So this is the piston type. Okay, this is a non-separator type. The non-separator type. Okay. So piston type. This is a piston type. This is a diaphragm type. By the particular shape of the accumulator, we can always make out whether it is a piston type, whether it is a diaphragm type, whether it is a bladder type. Okay, bladder type will be like this. Okay, this is a diaphragm type. Piston type. Okay. So now this is a diaphragm type accumulator. Okay, there is an elastomeric type diaphragm will be there, that is separating the gas as well as the hydraulic side. Okay, so this is a diaphragm type. You can see the operation. Okay, so when the hydraulic pressure increasing, it will be compressing the gas, and energy can be stored in the form of potential energy. Okay, in the potential form, energy can be stored. Okay, when the pressure, hydraulic pressure drops, that gas will pushing the oil backward. Okay, so this is how the diaphragm accumulator is working. This is a bladder accumulator. Okay, very most commonly used type of accumulator is this one. Okay, the gas will be stored in the bladder. Inside there is a bladder. Inside the gas will be loaded to the pre-charge pressure, and then it is closed. Okay, so this way, okay, and then this can be connected to the hydraulic side. So now when the pressure increases, the gas will be compressed. So it can work. So this is how the bladder accumulator is working. Okay. See, generally when a hydraulic system is there, you are setting the pressure. Okay. Suppose the pressure is 100 bar pressure you are setting. Okay. So that is the one pressure you are normally referring to. Okay. 100 bar pressure. That is the set pressure. But when you are using a accumulator in a hydraulic system, there are three types of pressures that is coming into the picture. One is the pre-charge pressure. Okay. When pre-charge pressure is there, you have the P0. Let us say pre-charge pressure is P0. Okay. So P0 and V0 will be the volume at that time. That will make it clear here. See here. Okay. So this is a, you pre-charge the accumulator when there is no hydraulic pressure. Okay. Or you may not have connected to the hydraulic side. Okay. You take to the pre-charging station and then you pre-charge it to the pressure of P0. Okay. At that time, you have a volume of V0. So the gas volume will be the what is the champ here now? That will be V0. So you have P0, V0. Okay. And then when you are operating the system, say when you are extending the cylinder will extend and then maximum pressure will be developed. That is a P2. P2 and V2. At that time, volume will be what volume available is only V2. When P2 pressure is there, you have the V2 volume. Okay, you can apply the Boyle's law here in the gas side. You can apply the Boyle's law. Okay, here, and you can get you can find out what is the volume available. Okay, if you know the P0 and the volume here, and P2, V2 volume, if you know P2 pressure and V2 volume, if you know, if any of this unknown factor is there, normally we have to find out V0. That is the size of the accumulator. The V0 is the size of the accumulator. Okay, that is the normal parameter we want to find out. Okay, so these are all assumed. Okay, P2 will be assumed. Then we can get other values. Okay, then we have also one more value called P1 and V1. This is in the midway between P0 and P2. Between P0 and P2, P1 value will be there. Suppose you set for 100 bar. Okay. Then we have to, in the design time, we have to assume some P1 value. So when the cylinder, suppose cylinder is extending, so while extending, the accumulator is supplying the energy. Okay. When the accumulator is supplying, okay, so the pressure should be reducing from P2 to P1. P2 to P1. It will not reduce to P0. Okay. By that time, cylinder should be extended. When cylinder is extended, okay, when P1 pressure is reached, now we see that the pressure is increasing again. Okay, the pressure goes again to P2. So in the normal operation, the pressure will be going, will be P2, it will reduce to P1, and again it is going to P1, P2. P2, P1, P2, P1, it will be changing. Okay, it will never come to the P0. P0 when it will come, when you off your system, when you turn off your system, pump is off. Okay, that time your hydraulic pressure will drop. Okay, if it is not trapped by using a check valve, if you are not trapping the pressure, it will come to zero pressure in the hydraulic side. But here in the gas side, you have the P0 pressure. Okay, that time only P0 will come. Otherwise, normal operation, the pressure will be P2, then it will come to P1. Okay, by that time now you set in such a way that, okay, when the full operation cylinder extends, suppose cylinder extends in 5 seconds. Okay, so after 5 seconds, the pressure will be P1 here. Okay, and after that, the pressure is again going to be increased. So again, suppose 90 is the pressure you design time. Now you selected 90. Okay, and this is 100 bar. Okay, and you have a relief throttle valve connected in the system. You adjust the throttle valve, throttlings, you adjust in such a way that for the full motion of the cylinder, okay, the accumulator should supply. Okay, that means the pressure reduces from 100 bar to 90 bar in 5 seconds. That way you should adjust the throttle valve. Okay, so you have a 90 bar pressure. Okay, after that cylinder when it is extended, pressure will not go down now. It will increase again. So again, it will increase to 100 bar. So that way it will be adjusted. So what I mean to say, when you use accumulator, you find three types of pressures: P0, P1, P2. Okay, normally that is the pressure you will find when you are using the accumulator. When you are not using accumulator, no question. Only P2 will be there. There is no P0, there is no P1 there. Okay, so this type of things will be there. So when it is a diaphragm accumulator, also same type. Okay, this is a normal initial when you pre-charge the accumulator with the P0 pressure. That time the size of the accumulator will be V0. So the V0 is the size of the accumulator. Okay, so these two parameters are also important. Okay, but P1, V1 generally in between in a operator also will not see, but it will be coming to some mid value and it will go again up again. So generally the high pressure only we are interested. Okay, so this type of pressures will be there in the system. So here also it is a little bit, it is showing P2, V2 it is showing. Okay. So it should not come back to the fully to the pre-charge pressure. It should be midway. Okay. Again, it should be increase. That way it should be there. The bladder accumulator. So pre-charging. Okay. Now we come to the pre-charging. How much is the pre-charging pressure? Okay. That is one issue in the hydraulic system. Okay. We have to pre-charge the hydraulic accumulator to certain value. Okay, so that depends upon your system pressure. Suppose system pressure is 100 bar, okay, then the pre-charge pressure should be around 80 to 90% for energy storage applications. Okay, in hydraulic system, now if you are having an energy storage application, the pre-charge pressure should be 80 to 90% of the minimum system pressure, not the maximum system pressure. Okay. So when you are designing, you decided 100 bar pressure, the system pressure. So that is the P2 pressure. Okay. You have to also assume a value of minimum system pressure. So you take it as a 90 bar. You can take any value. 95 you can take, 90 you can take. Okay. So generally that will no. So that selection will affect you the size of the accumulator. That's the only thing taking place. If you take 95%, then your size of the accumulator will be still larger. Okay, say 90 to 95 it comes. Okay, that time it should supply the required oil to the system. Okay, so size of the accumulator will be larger. When you take to 90%, the size of the accumulator will reduce. 80% still size of the accumulator can be reduced. So that way. So some 10% you can take. So 10% you can take the value. So 100 bar is the maximum pressure. 10% is 10 bar. So the minimum system pressure you can take it as 90 bar. Okay. Then your pre-charge pressure for energy storage application will be the 80% of the 90 bar. So how much? 80% of the 90 bar. 72 bar. 72 bar. So 72 bar should be your pre-charge pressure. Okay. So that way you can decide the pre-charge pressure for the energy storage application. For pulsation compensator, the shock or shock absorber, the pre-charge pressure can be 65 to 80%. Okay. So these are all designer will decide what should be the value, what should be the percentage. Okay. So depending upon the type of application, he will decide and he will decide the pre-charge pressure. Okay, so that will be decided, and pre-charge pressure will be in your drawing also. Ongc drawing, when you see side by accumulator, pre-charge pressure will be mentioned. That is the gas pressure which you are charging the accumulator. The nitrogen pressure, that is the pressure that will be specified. That is the P0. Okay, then you will have a maximum system pressure. That is the P2 pressure, maximum system pressure. That also will be specified. Maybe nearby the relief valve, it will be written, that pressure. Okay. Minimum system pressure you won't find anywhere. That is only designer knows. He would have designed accordingly and the sizing will be done accordingly. Okay. That is the P1 pressure. Normally, operator or any circuit diagram also, it won't be mentioned. Okay. Only the P0 and P2 pressure will be mentioned. Okay. So now Okay, so accumulator is used for energy storage applications. Normally we trap the energy. See, hydraulic high energy is coming through the hydraulic system. That high energy can be trapped. Normally we keep a check valve, okay, and check valve, will allow the flow in one direction. Okay, the flow will not come back. So the energy can be trapped in the other side. High pressure can be trapped. Okay, so now when you turn off your pump, so when you are charging the accumulator and then you turn off the pump, okay, we can expect some energy stored in some part of the circuit. Yesterday, last class also we have seen, somebody was asking, some places in the hydraulic system, the pressure was trapped. Suppose a 4x3 closed and center position valve when you use, some part of the circuit energy will be stored. Similarly, in accumulator circuit also, deliberately we are trapping the energy. Okay, so that whenever the requirement is there, we can take the energy. So we use a check valve and you trap the energy. Even if you switch off the pump, that energy will be there only. Okay, so what the maintenance person should know is that when the pump is off, you should not think that the complete there is no energy anywhere in the system. So when you try to open some component you are opening, okay, some hose you are trying to remove, some 100 bar or 300 bar pressure will be there in the system. It may be dangerous. So there will be fluid injection. There will be fluid injection. High fluid injection will be coming out. Okay, that may go into the skin. It may be dangerous. Okay, so what is required in systems with the accumulator is that we have to isolate the pump from the accumulator first. Okay, there is one requirement is we have to isolate the pump and the accumulator. So there should be a shut-off valve required. Okay, and then the trapped energy should be relieved. For that we have to use a bleed valve. Okay, there is a bleed valve. I think last time also somebody asking now what is the purpose of bleed valve. Okay, so the energy has to be relieved. So there is a manual bleed valve will be there. There may be optionally there will be a solenoid operated bleed valve. Okay, and solenoid operated bleed valve will be there. Whenever you turn off the pump, automatically the solenoid will be de-energized. The normally open type of valve will be there. Automatically it will be bleeding the trapped energy. So that type of arrangement also possible. But usually that is an optional thing in the safety requirement. It's an optional thing. Okay. So definitely isolating valve will be there. Bleed valve, manual bleed valve should be there. Optionally, you should have a solenoid operated 2x2 valve will be there. Okay. And optionally, there is a pressure relief valve also. Because sudden shock pressure comes, it should not affect your accumulator parts. There may be some elastomeric parts you are using. High pressure comes, so that should be relieve the pressure. Okay, that should be safe. Safeguard the accumulator parts. So there will be pressure PRV also used optionally in the case of accumulator. So that is called accumulator safety block. This is accumulator safety block here. This is accumulator. Okay, this is accumulator. This is accumulator. Okay. So along with that, associated with that, there is a safety block will be there. So always you will find a safety block associated with the accumulator. So here, what are all things you will find? This accumulator is there. This is a pump is there. Okay. This is a safety block. Whatever this block, that is a safety block. So in that, there is a main shut-off block. Okay. So when you want to carry out a maintenance work, you have to first shut off here. Okay. You operate this valve and this shut off. You isolate the accumulator from the system. Okay. Okay, and then there is a manual bleed valve which is connecting to the tank. Okay, the tank is there. Okay, so when you operate this bleed valve, whatever energy stored, trapped, that will be going to the tank. So this is through the manual bleed valve. You can operate that valve. You can relieve the pressure from the system wherever trapped energy is there. So that can be relieved. Okay, and ensure that use a gauge. You can use a gauge. Ensure that pressure is going to zero again. Okay, for that gauge also must be used. This is to ensure not only say when you are operating the valve, probably inside it is nothing is changing. That possibility also there. you are operating the lever, only lever is operating, but inside it is not changing. Your pressure may not get relieved. Okay. So in accumulator circuit, what we say, not only you release the pressure, you have to ensure that it is getting relieved. So you can use a gauge for that purpose. Okay. This is a solenoid operated valve, bleed valve. Okay. It's a normally open type valve. Okay. Normally open type valve. Okay. So when you on the pump, this will be solenoid will be energized. It is linked with your pump. When you on the pump, this solenoid also will be energized. Okay, then it will operate this 2x2 valve. It will block. Okay, that time pump can charge the accumulator. But when you off the pump, okay, this supply will go automatically by spring. It will come back. Automatically, it will relieve the pressure. Automatically, it will relieve the pressure. For that, the solenoid operated bleed valve is also used. Okay, but this is an optional. The manufacturer will give an optional. When you are purchasing, there is a optionally this available. You click, you check that box. They will supply as per this one. This is a relief valve. Okay, because there is a possibility of high pressure, shock pressure developing here also. So system pressure may be 100. This may set for 105 bar. So when high pressure develops, it will relieve the pressure to the tank. So this is a safety and control block. This block is there. You can see that. Okay, safety and control block here. Okay, this is one. This is a part. Okay, this will be connected to the accumulator. One side connected to the hydraulic pump side. Okay, what are all things here? You can see one is a block. This is a block, safety block. This is a 3 is the accumulator. The accumulator. 4 is the pressure relief valve sealed with lead. Pressure relief valve. What is that pressure relief valve? 4. This is a pressure relief valve. Okay, this is a pressure relief valve. Then this is a discharge. 5 is a discharge. This is a discharge. 5. Okay, this part is a discharge part. Okay, this is the discharge manual. Bleed valve. This is a bleed valve. Okay. This is a pressure relief valve. This is a bleed valve. Then discharge electric optional. Electric optional 6. 6. This is a 6 one. Okay, this is a solenoid valve. So electric supply. You have to give the supply. Okay, then this valve will be operated. So accordingly, it will operate. 7 is a shut-off valve. This is the main shut-off valve. This is to shut off the accumulator from the pump. So this valve will have to operate. This one. So the position will be marked here. On and off position will be marked here. So accordingly, seeing that you can, you can ensure that it is off. It is isolated from the pump. Accumulator is isolated from the pump. Okay, so it will be marked here. Which is off, which is on. So that it will be marked. 8 is the P port. 8. So backs, here. This is a pressure port. And 9 is the gauge port. And pressure gauge, if you want to use, you have to insert here. You have to install here. So this is the safety block. It is always to be used along with the accumulator. Okay, now we'll see the comparison. Okay, so we have seen the different types of accumulators, especially the gas charged accumulators, diaphragm type, bladder type, and piston type we have seen. So size wise, diaphragm type is maximum size is available is only 3.5 liters. Maximum you can get up to 3.5 liters. Okay, so small application, small flow requirement, say less than 150 LPM, you can use a diaphragm type. Then bladder type, you can get up to 55 or 50, you can say 50 liters. The bladder type, maximum you can get up to 900 LPM. Piston type is a very large flow requirement, is there, greater than 900 LPM. I think this is greater than, I think so. Up to that, very high flow rate requirement, you have to use a piston type. Okay, and you can get a size of more than about 1350 liters. Large size, okay, accumulator. Now, very large amount of energy to be stored. You have to use a piston type accumulator. Otherwise, normal application bladder type is used. Then heaviness, lightweight. Diaphragm is lightweight, bladder is medium weight, and piston is a heavy weight. Cost wise, diaphragm is low cost, bladder is a medium cost, piston is a high cost. Application suitable for small volume, small flow rate. You can use a diaphragm type. These are best for general purpose application. Bladder type. Best for large volume, large high flow rates. Okay. Suppose now we have seen some application is we want to store energy for 2-3 cycles of operations. Then you may have to use a piston type. Depending upon the flow rate requirement and size has to be decided. And then sometimes you may have to select a piston type accumulators. It all depends upon the
2500 bar pressure.
yes. Up to that it can withstand. Yeah. See nowadays we are also using even 3500 bar systems are also available.
And where is the typical application?
In some applications it is used, like metal compactation, high pressure 3500 bar systems are already there.
And there is 2500. Means what about that? Pump capacity.
All should be that size. That range. Yeah, but it is available. Suppose you want to use accumulator in that system, you can accumulator is available for this type of pressure. It is available. So it is used for shock suppression. Okay, good. Okay, bladder and diaphragm. See shock suppression means what? The response time. Okay, yesterday also very nice question you were asking. Response time. Okay, suppose if a heavy piston is there, response will be slower. Okay, when sudden shock is coming, it takes some 10 millisecond delay. Okay, then it is not very good. Piston is having a aluminum piston, not only we are using. Okay, but diaphragm is a elastomeric material, lightweight. Okay, so bladder and diaphragm is a lightweight, so it is good for shock suppression. Whereas piston, it is not so suitable. Okay, but energy storage also we can use. Energy storage application, all the three we can use. But shock suppression, especially these two are very good. Diaphragm and bladder type we have to select. Okay, piston is if that much flow rate is there, then piston we have to use. Okay, but still lightweight you have to make the piston. If any lightweight piston is there, that we have to use. So this is the idea we are getting. Now the mounting position is one important aspect. Generally, accumulator should be mounted vertically. Vertically, it is the best position. Okay. Sometimes in application it is difficult. Okay, suppose space may not be there vertically, horizontally or some angle we have to install. Okay, so diaphragm type and bladder type you have to any position you can install. Okay, vertically or horizontally or any angle you can install. Okay, but when it is vertical, it is very good. Okay, but if it is angle or horizontally if you install, up to 15% you have to downgrade its capacity. Should be downgraded. Okay, and the problem is when it is horizontally, a lot of contaminants will be settled. It will be collected in the accumulator. If it is vertically, it will come, oil will come and oil will go out. Complete oil can be relieved. But in the horizontally, when you install, some of the oil will be trapped in the accumulator. So there is a possibility of contaminants getting settled inside the accumulator. So that is not advisable. But if the situation is like that, your installation situation, you are not able to having that space for vertically to install. So you have to install horizontally. You downgrade, say capacity, to some pressure, or something, 15% you reduce. His life itself will be reduced by 15%. So you can see the parameters. Okay, so the piston accumulator, the pressure rating is up to 200 bar pressure. Okay, so this is the size. You can see how much liters. These are the liters. So 0.95 liters to 37.9 liters. It is possible here in this size. These are the liters. These are piston accumulators. In some manufacturers will give some other accumulator diaphragm type. Okay, this I just projected more. So diaphragm is up to 3.5 liters. Okay, whereas bladder type you can get up to 50 liters. First 30 liter, some application required. You can select a bladder type accumulator. At that time, diaphragm type accumulator will not be. It is not available. Maximum you can get up to 3.5 liters only for diaphragm type. Small size only available. Bladder type medium size up to 50 liters available. If piston type, again still higher type is there. There we can see here. Piston type. Okay, it is not here, but it is available. Okay, so I have seen. This also is. This is also diaphragm type. There is only 2.8 liters available. Okay, the safety block. A safety block main parameter is how much flow it can pass. The flow rate requirement is an important thing there, and pressure rating, how much pressure it can withstand. So these are the normal parameters which we select there. Size of the shut-off valve, it's a DN. Okay, it's a 10 size, a 20 size, and like NG10 we are saying, no? Last class we are saying NG10, NG20, NG32. The size important when the shut-off block, you know. This is say the flow has to go through the valves, so that is important there. Okay, now we are coming to the application. Okay, one is the shock absorption. So generally, shock absorption means suppose this type of valve is used in a hydraulic system. Cylinder has to be operated by a valve, and you are using a pump and relief valve setting you can do here. Some pressure can be set here. Now you suddenly operate the valve. Okay, there is a possibility of shock pressure developing here. In this part, there may be a shock pressure. Okay, that will act on the pump parts or anywhere in the relief valve. The shock pressure may come. Suppose you set for 100 bar, maybe suddenly when you close the valve, there may be 150 bar here. Okay, if you connect an accumulator like this, connect an accumulator, when you operate the valve, any shock pressure comes, this accumulator can absorb that shock like a spring. Okay, like a spring, no? This can absorb the shock. Okay? It will protect the other vulnerable parts, you know, like pump or relief valve or any other check valve is there. Any other thing, no, it can protect. Okay, if you connect an accumulator, so that is the idea. Okay. Now, if it is an energy storage application, we have to trap that pressure. So we have to use a check valve. Okay, your pump is there. Pump will pump to the system, to the cylinder. Okay, and when the sufficient pressure is developed, after that we start charging the accumulator. Okay, when accumulator is charged, that pressure will be trapped here. It cannot go back anywhere. It cannot go back anywhere. Okay, only thing it will go to your unloading valve. Okay, unloading valve will be operated. Okay, and then it will open the pump will be opened to the tank. So pump will unload to the tank. Okay. So it will not affect the whatever energy stored here, whatever energy charged, that will be still there only. Okay. This is static pressure. The static pressure, it will not flow. It will act on the unloading valve and it will keep it open. Okay. So that pump can unload. That way it will be there. So whenever you operate the valve, okay, when cylinder start moving forward, that time it can discharge. The accumulator can discharge, and then along with pump, it will also supply. So pump will be 8 LPM, this will be 2 LPM. So totally 10 LPM going into the pump, into the cylinder. Okay, so that can be maintained. So that way it will work. So when cylinder is extended, again the accumulator will get charged. So when it is coming back, again accumulator can supply along with pump. Okay. So that way energy storage is possible. Energy storage, whatever stored energy can be used to the next cycle. Next operation it should be used. So that way only we can store the energy. The stored energy can be utilized. Okay, in the hydraulic side. Not like pneumatic. The pneumatic you store in a big tank. Okay. So that energy is used continuously into the system. Okay. So that system, the cylinder will be operating or the motor will be operating in pneumatic. Okay. Like that we cannot use in the hydraulic. Whatever stored energy should be used in the next cycle. That way only you can use. If sufficient energy is there, 2-3 operations you can carry out with that energy. that way we can do. So what is the difference when you are going to have a energy storage application? Okay, when you are having an energy storage application, usually there will be a check valve used. A check valve used. Earlier, shock suppression we are not using. In shock suppression we are not using. Simply we connect to the accumulator. Okay, in this part. Okay, we use just before the directional control valve. Okay, and nearest to the this valve. Okay, nearest to the directional control valve. Okay, DC valve. You have to connect the check valve. Okay, so suppose this is 10 meters. Okay, so very close to the DC valve, you have to connect the accumulator, because now all this part will be protected by the accumulator. If it is connected here, this part of the hose or a conductor will be affected. That's why it is close to the directional control valve we have to use. The accumulator should be connected close to the source of shock, where the shock is developed. That source of shock, nearest to that you have to connect the accumulator. So here the shock source is the valve operation. That's why I told like that. Here the energy storage application, what difference you find? You will find a check valve. So to trap the energy, you are using a check valve. And if you want unload, usually there will be unloading valve also. Will be seen in the circuit. So this is a very typical in hydraulic circuit. You are using an accumulator for energy storage. You'll find a check valve. You'll find an unloading valve. Okay. This is what the starting one circuit we have shown, one company. That module they are giving. Check valve and the unloading valve module they are giving. Okay, and they are connecting like that. And an accumulator also shown. The morning first circuit that I have shown, it was showing like that. Okay, now we'll simulate this one with the software. You see the problem. I have to click here. No, it's okay. It's okay. Now it has come.
Yeah, don't share.
No, first that fluid sim
Should be closed.
No, clicked.
Okay.
Opened, then only it is coming. Not coming, no?
Please.
Okay, I will.
And this one first. Copy and paste.
This one feedback also she will handle.
Standard for
So this is a general circuit. Okay, there is a power pack is there. There is a cylinder is there. Direction control valve is also there. Relief valve. Okay, but I cannot simulate a shock. I cannot create any shock in this software. Just operate and see. That's all. So cylinder is extended. Very quickly, if I operate, there should be some high pressure should develop. But in the software, no, simulation software, it is not possible. Okay. So very, very quickly, if you operate, the high pressure should be developed there. But okay, just to show that, so I am making the circuit. So this is this one, okay. Now accumulator is also getting charged, okay. So this is a gas pressure actually, 73 bar or something, 74 bar. This is inside a nitrogen gas pressure, that is what is shown there, okay. But we cannot simulate here any shock, okay. Shock means, say I operate, when I operate here fast, so the shock comes, it absorbs. It cannot store any energy, okay. So when the pump is switched off, say I am switching off the pump, okay. So whole energy will be lost. All go to the tank. So this I use to stop pump. In simulation software, that is also not possible. Madam, also here also we cannot stop the pump. When it is on, it cannot stop. So what I do is to connect a 3x2 valve, and this can be operated. Okay. So then, so it is separated. This part is separated from the pump. So whatever the flow is there, it will go to the tank. So this is equivalent to stopping the system, stopping the pump. So that way, how it will be there. So you can see that the energy is not trapped here in the accumulator. So this is for the shock absorption. Okay. So now we'll see the energy storage application. Okay. Before that, this also, whatever we told. Okay. This also okay. So this is a P0 V0. So this part you can see here. Okay. So earlier I was talking about this one. 1 minute. Just, So there is an accumulator. So it is charged to pre-charge pressure to a pressure of 45 bar. You can see it is pre-charge pressure is 45 bar. Okay. So that pressure is showing. Okay. So now this is a pump which is getting connected to the cylinder. Okay. So here there is a P2 V2. It is getting charged to the pressure of maximum pressure. So simulation, I make it to the real time. Okay, this is a real time. It is getting charged. So what is the charge pressure? 60 bar. System pressure is 60 bar. Maximum pressure is 60 bar. So I am not connected in relief valve. Internal relief it is taking care. Okay. So this is 60 bar. Okay. So now the gas gets getting charged up to 60 bar now. Okay, from 45 it is changing to 60 bar. So gas is charged now, it is compressed. Okay, now the pressure is 60 bar. Okay, so now if you operate the cylinder, what will happen? Okay, okay, now I'll make slow motion. Okay, little slow motion I'll make. Okay, it is getting charged. Okay, you can see that check valve is opened. It is getting charged. Okay. When it is discharging, now it is supplying to the cylinder. I put a throttle valve. Okay, so that now it should supply. It should not supply. Suppose 10% of the time it has moved. Complete charge should not go to the cylinder. It's spread out to the period, complete period. Okay. Now it is hydraulic pressure is developing. That's all. Okay. The pre-charge pressure will be minimum 45 will be there. This is a hydraulic pressure which is acting here, that is being shown. So it will develop up to P2. Okay. So now it is developed to 60 bar. Okay. The pressure is now 60 bar. This is a P2, and whatever volume will be there, that is V2. Okay. That is the one we are. Now we are operating. Okay, cylinder. When cylinder moves forward, okay. Suppose it takes 5 seconds for the cylinder to extend fully. Okay. This pressure should drop slowly. Okay. And then it should supply oil to the cylinder. Okay, along with the pump also. So now it is reducing 50, 55, 54, 53, 52, 50, 49. See now 49 again it is increasing. Okay, when cylinder is extended fully, so 49 is the P1 pressure. Here 49 is the so once 49 bar is reached, again it start increasing. That means cylinder is extended, then pressure start increasing. Okay. So 60. Now I will release. So again, what is the pressure? 56, 55, 54, 53, 54. Okay. Again, it start increasing. It will not come to 45. What I mean to say, it will not come to 45. Okay. That way it is moving. 54, 53, 52, 51, 50, 49. Again, 50 it is increasing. It is not coming to 45. Up to 49 it is coming. Okay. That is what I mean by V1. Okay. So by design now we are doing that. Okay. We will not allow that to come to 45. Okay. We should design in proper way so that it will not come to 45 again. Little above that it should come. So that makes, okay. So that's why we are taking the pre-charge pressure equal to some 80 to 90% of the minimum system pressure. That 49 is a minimum system pressure. Okay. Some percentage of that should be less than that. Okay. That must be the pre-charge pressure. That way you are setting it. Okay. We are not setting the pressure, pre-charge pressure. Okay. Some percentage of the maximum system pressure. Okay. It is the 80 to 90% of the minimum system pressure. That is the pre-charge pressure. I hope you understand what I mean. Okay. So this is what, so there are three pressures you find here. You'll have three volumes also accordingly. So when P0 is the pressure, that is the time volume will be V0. When P2 is the pressure, that time volume will be V2. That will be less volume. Okay. When pressure is P1, the mid volume will be there. Okay. That is the V1 volume. I think this will.
Why it is only reaching to 49 only?
Yeah, that's what that way. See, I adjusted the throttle valve, adjusted the throttling in such a way that, okay. So suppose I change, okay. I open 50% opening. Okay. So now what happens? Quickly it will supply the whole, okay. Not only pump, more supply will go from the accumulator. If it is more opening is done, okay, let the pressure develops here, okay. The pre-charge develops. I had to set this pre-charge to, oh, that's why, 45. This 45, if I set, pre-charge I set for 45. There is a gas pressure. The 45 is there, okay. See, 45 onwards it will start developing. Now this throttling I reduced. Okay, more opening I have given. Now what happens? This will be expanding fast. Okay, this oil can go to the cylinder fast. Now the pressure will drop. See? Let it develop to maximum. So maximum 60 bar. The pressure system pressure is 60 bar. Maximum set here. Okay. Now it is 57, 54, 52, 51. Oh, it is only that much, no? So I will make it 100% open. Okay. is opening, no throttling. If I am not doing any throttling, so what will be the effect? The accumulator is charging. 45 onwards it is charging. Okay, now it is
Sir, I think during charging it is going to check wall, right?
that is there. Charging time, no problem. But the discharging time, what I have to adjust. See, now you see. Okay.
Again, here it is only doing.
It's only here, only that much. But the simulation, now there is some problem. My selection not correct. Okay, displacement, pump displacement is very low. Okay, so default also 2.4 liters is there. Okay, because the pump flow is very low. See, generally pump flow will be more, accumulator will be some percentage of that, maybe 20 or 30%. Okay, suppose 10 LPM is supplying. We have to make in such a way that some 2 or 3 LPM this should supply. Okay, so that way only this is generally done. So that you can do with restricting the flow here. Okay,
Actually, what I mean to ask is like we are setting any pressure P1.
Any pressure P1 means P1 not any pressure. Okay, see generally suppose if it is a 60 bar is done here now, system pressure. Okay,
Yes.
some 10% less you can design. Okay, suppose 10% if you take, so 60 bar is the maximum pressure, so 10% will be 6 bar. Okay, so 60 minus 6
54.
plus, 6 is 54. Okay, so that will be the value which is coming, 54 bar it will come. Okay, so then the pre-charge pressure will be some 80% of 54. Okay, so it will be as per that it will be designed. The design pressure, no, design time, no, that will be the size will be decided for the accumulator. Okay.
It is a designing
Value.
characteristics.
P1 is a design value. Afterwards, nobody will know. Only designer will be knowing. P1 value will be known by only the designer. Okay, but that will affect your size of the accumulator.
Means it is not like it automatically is
No.
designing the pressure. Like it is already designed for this pressure only.
It is designed for that. Okay. Only thing, see, when it is designed for that, what we mean, see, 60 to 54 bar when it comes, your cylinder motion should be completed. Okay. The speed should be in such a way that, okay, you should adjust the throttling. No, you should adjust that throttling value such a way that it should supply that much volume of from the accumulator to the cylinder. That should be spread over to the complete period.
I don't understand what is the use of this P1.
No, P1 is value is required. Okay, I think we'll see some more thing. Okay, we have to understand some more thing. Then only we'll understand the meaning of that. See, that's the reason I am telling now. The size of the accumulator also depending on that. Okay, suppose you take
what's happening in the simulation is like
no, simulation not possible. In the simulation, it is not. It is not designed. It is not showing that actually. In the simulation, okay, they're not designed for that. Okay, it is not. So I am trying to show something. Okay, we are not able to see that clearly in the simulation. Okay, so that is the problem is there. Okay, simulation is not meant for that. To show that one. Okay, what I will do. Okay, I'll show us a little more mathematics.
Sir, can we have a video on this?
Video of no, I'll see. Okay. See what you have to understand. Little more theoretical input is required. Okay. Okay. So little design type will go. Okay. Are you able to see? So there is a cylinder here, there is a pump here, and the accumulator here. This is charged to P0, V0. So this is the size. P0, V0 is the size of the accumulator. Okay. So what is the size of the accumulator? V0. That you understand. Okay. Now, when the pump is on, what will happen? When the valve V2 is closed, valve V1 is open. Okay. Here both are closed. V1 is closed, V2 is closed. Okay. So accumulator will be now we charge accumulator. We charge it to V0. Okay. Gas will be charged, and the pressure will be P0. And what is the volume available is V0. So that is the size of the accumulator. Now you open the valve. Okay. Now what happens? Pump will pump and the charge is charging. Accumulator is charged. What happened to the gas? Gas is getting compressed. Okay. So gas is getting compressed. Okay. So the pressure is becoming P2 here. Okay. The P2 is the system pressure. That much pressure getting developed in the gas also. So gas pressure is changing from P0 to P2. P0 to P2 it is changing. So it is it is obeying the, we can say, if it is a isothermal compression, it is obeying the Boyle's law. Okay. P0 V0 equal to P2 V2. I think is that you know. Okay. P1 V1 equal to P2 V2. That is the Boyle's law. You know the Boyle's law?
Yes, sir.
Yeah. P1 V1 equal to, say P1 V1 is a constant, provided temperature remaining constant. There is the isothermal. Temperature remaining constant. Isothermal process. Temperature remaining constant. Okay. The pressure and volume. Pressure increases, volume reduces. Volume increases, pressure reduces. Okay. As per that only compression process taking place. Okay. If the temperature is remaining constant, we say it is isothermal process. Okay. There are other type of compression also, like adiabatic compression. Okay. Adiabatic compression means okay, there is no change in the temperature. Okay. Okay, there is no change. Okay. So very fast operation. Suppose very quick operation, quick compression, very quick release. Okay, that type of we say there is no time for the system to add heat or remove the heat. Okay, so fast it is operating, you are not able to add heat. Okay, or discharging time also, you are not able to remove the heat. Okay, so the temperature remaining constant. Now, very fast operation. Isothermal, we normally say temperature remaining constant, very slow operation. So you are compressing in 1 hour, or 1 day you take to compress to 6 bar. 1 day you take to compress to 6 bar, it's slowly compressing. So when heat is added, immediately heat is removed. Hot heat is added, that heat is removed. That type of operation is normally isothermal. Followed. So very slow operation, very slow discharge, we normally take it as isothermal. Very fast, quick charging, quick discharging. That we normally take it as adiabatic. Okay. So adiabatic means it is not obeying the Boyle's law. So PV is not a constant. That is not true for adiabatic. Okay. PV to the power of n. Some power is there. P volume n. Volume to the power of n. Okay. That volume is n value is 1.4 for adiabatic. Probably some of you may be knowing this. PV to the power of 1.4 is a constant. Okay, so that is the equation applicable to the adiabatic compression or adiabatic decompression. Okay, so that value you have to. So you have to take P1 V to the power of V1 to the power of 1.4 equal to P2 V to the power of 1.4. Like that you have to take. That 1.4 term will be coming in the adiabatic compression. Okay. And there is a true compression, that is a polytropic compression. There is a true compression. So it is the n value is in between 1 and 1.4. Okay. If it is 1, it is a isothermal. If it is 1.4, it is a adiabatic. In the polytropic compression, the value will be in between 1.2, 1.3, like that. Values are normally taken depending upon the type of gas. Okay. Used and all, okay, the value will be given. So that is the polytropic compression. Okay. With that understanding, now we go here. Okay. So initially P0 V0, then when the fully charged P2 V2. Okay. When the system is working, the pressure will come to the P1, then again it will go to P2. It goes like that. So now when you see here, okay. Board I can use.
Yes, sir, we can use.
Can use a board. 1 minute, the board I will show this equation, how it has come. Okay, the accumulator volume V0 has come. I'll show on the board.
Excuse me, can we take a lunch break? Lunch break will continue and we'll be having some doubts, means we'll discuss later. Is it okay if we take a lunch break?
Okay, madam. Okay.
Okay, I will continue from the here. Okay, by that time now I have to use the board. Then I will say how this equation has come. V0 equal to this equation has come for the isothermal condition. Okay, so we are able to find out the accumulator volume. Okay, and then the P1 term is there. Okay, that will also decide the accumulator volume. It affects.
Sir, ultimately, it is only for the displacement of piston. The pressure is getting discharged from
So,
the.
yes, accumulator has to supply energy to the cylinder. See, some volume. Okay, suppose cylinder volume, total volume is 10 liters. Okay, 8 liters should be supplied by the pump, 2 liters should be supplied by accumulator. So that 2 liter is the difference between V1 and V2. That V1 minus V2 is the volume we have to supply to the cylinder. Okay, that should be 2 liter. Then it will be able to supply.
Like
Okay,
it
anyway.
is for intermittent displacements or.
I will explain. Okay, after lunch. Okay, because there is nothing here in this. Okay, on cylinder also I will show accumulator and how this equation has come. Okay, I can show that. Ultimately, you have to supply to the cylinder. Okay.
Now, has that simulation is working? For all of you, just check once again. Any doubts is also after lunch we can discuss. Is it okay?
It is working
Yes,
fine, ma'am. It is working fine.
Okay, ma. Thank you, ma. Thank you. Good afternoon to everyone. We'll start our afternoon session. Please, all of you join the session, please. 3 are missing. Okay, we'll take now attendance. All are present?
Yes,
Hello?
ma'am.
Okay. Okay, any doubts you have? Any doubts so far? So far from last Monday. You can ask our expert Goji sir. He will answer all the things, whatever the doubts is there. But be attentive in the classes. He will explain now accumulator. Yes, sir.
Okay, so we continue from the before lunch, whatever the issues. Okay, the accumulator is there. The accumulator. So the gas side. This is the fluid side, hydraulic fluid. Is connected to the hydraulic system here. There is also total valve connected. So this is the cylinder. Okay. So we are controlling that cylinder. Okay. And we have to supply the oil to whatever volume is there. Okay. Suppose this is 10 liters. Just a numerical value. So when 10 liters has to be supplied. If the accumulator is not there, then that 10 liters should be supplied by the pump. So this will be 10 liters LPM. So 1 minute to suppose if you take that much oil it has to supply. So this is the volume I am taking. Okay, this is the 10 liter it has to the whole 10 liter it has to supply. Okay, not the rate. Okay. Now, if we are connecting an accumulator, suppose we are using an accumulator. Our aim is to supply some portion of the fluid to the cylinder. Okay. If not fully 10 liters. Fully 10 liters accumulator need not supply because even pump also there. So suppose this has to supply some 20%. Accumulator has to supply 20% to the cylinder. Okay. So what is the 20% of that? The 2 liters. 2 liters the total volume here. This 2 liters should be supplied by the accumulator. This 8 liters should be supplied by the pump. So this is the volume we have to find out. How much accumulator has to supply? Okay, how much volume of oil accumulator has to supply? So how much oil? Say this is the when it's fully charged, it may be like this. When it is fully charged, here it is P2, it is V2. The pressure will be P2 in the gas side. Okay. So here oil is coming here and it is getting charged. Okay. So here also P2 will be there. The same P2 will be here also. So this is the pressure developed is P2 here. Okay. So now it is like this. Okay. And you are operating this valve and the directional control valve is operated. The cylinder starts moving forward. Suppose it takes, say, 5 seconds. Fully extending, it takes 5 seconds. Okay. So throughout the 5 seconds, the 2 liters has to be supplied by the accumulator. Throughout the 5 seconds, 2 liters should be supplied by the accumulator. So accumulator will supply, suppose this is from here, when it changes here, okay, the dotted line and put, this is corresponding to 2 liter. The volume change is a 2 liter. So this change in the volume, now where it will go? This is a liquid, earlier oil was here. Let us change it to here. 2 liter has displaced. It has gone to cylinder and it is supplied. But it should supply for the throughout the 5 seconds. So otherwise what happens? Suppose in 1 second only 2 liters supplied, again it will supply. So that we want to avoid. So what you have to say, 2 liters per 5 seconds. So that rate it has to flow. That means how much it is? 2 by 5 liters per second. Okay, so that rate it flows, liters per second it flows. Okay, in 5 seconds 2 liters will be supplied. For that only we are using this total valve. So that you adjust and you have to rate, you have to adjust. so that in 5-second time 2 liter will be supplied. So that you can adjust. So now the pressure is P1 here. Now the pressure has changed to P1. Okay. The volume is now it is like this. Okay. The gas volume is increased. In the gas side, when you take, the volume is now V1. With the pressure P1, the volume V1 here. Earlier it was like this. Okay. Up to this. So this is the P2 V2 here. So this change in the volume. Okay. That corresponds to what it has to supply. That we have to first we have to tell. So that you can find out what is the cylinder bore diameter, okay, and what the stroke length, maybe 100 mm stroke length, okay. So 20% of that accumulator has to supply. So 80, 20% means 20 mm distance. What the volume is there, that much oil accumulator has to supply. So that is what so that we can find out. Pi d square by 4, that is the volume, okay, and area into the stroke length. Okay. Into the percentage, this one, 20%. So that much only. Okay. You need not supply 100%. Then what pump will supply? Okay. So that is not required. So the 20% only to be supplied. So this is what is to be supplied by this one. This is nothing but V1 minus V2. This is nothing but V1 minus V2. This should equate. Okay. So V1 minus V2 is equal to this much volume.
Displacement.
Yeah. This is the area, this is the stroke length. Into 20% accumulator has to supply. So that is what is V1 minus V2. Now, if you see the pressure condition, okay, so initially P0, V0. That is the pre-charge pressure and the corresponding volume. When it is fully charged, P2, V2 will be the pressure and the volume respectively for this. Okay. But we are also keeping in between one value, P1, V1. Okay. So when it is discharging, we are not allowing to come to P0, V0. Even if it allows, no problem. But normally it is in between some value will be there. Okay. Because now gas charging, gas expansion, so we cannot exactly, the accuracy will not be there. So we keep for safer side, P1 is the pressure, intermediate pressure, and V1 will be the volume. Okay, so that we keep. So let us say this is all isothermal. In isothermal process, combustion expansion process, okay, we know that P0, V0 equal to P1, V1 equal to P2, V2. Okay. So this is a for isothermal process. P0, V0 equal to P1, V1 equal to P2, V2. So our aim is to find out what is V1 minus V2. So what will be V1 here? From these two, we find out V1. V1 is equal to P0, V0 divided by P1. Similarly, we will find out V2. V2 is equal to from these two. From these two, P0, V0 equal to P2, V2. So what will be V2? P0, V0 by P2. So what will be V1 minus V2 now? Now we will find out V1 minus V2, which is equal to P0, V0 by P1 minus P0, V0 by P2. Now, ultimately, our aim is to find out what is V0. V0 is the size of the accumulator. So, V0 is equal to, okay, V0 we can make it common here. V0 equal to P0 by P1 minus P0 by P2. They are able to see now.
Yes, sir. Yes, sir.
So, this is what is V1 minus V2. This is nothing but V1 minus V2, which is equal to V0 into P0 by P1 minus P0 by P2. So, what is V0? Equal to V1 minus V2 divided by this one. P0 by P1 minus P0 by P2. This V1 minus V2 is this value. What the accumulator has to supply, that is V1 minus V2. That is nothing but pi d square by 4. Pi d square by 4. That is the area of the cylinder. And what stroke it has to supply. The stroke into the percentage. This can be taken as a complete stroke length of the cylinder. Okay, how much stroke it moves and how much percentage the accumulator has to supply. So that is what is this one divided by P0 by P1 minus P0 by P2. So this is the size of the accumulator. Okay, required to supply this much of oil to the cylinder. Okay, this is the equation we have to use. Okay, so we'll be able to find out the V0 value. Okay, so in this V0 it depends upon the P1 value. P0 by P1 minus. So how much value you select P1, okay, that affects the V0 value. Okay, here only it affects. Okay, so otherwise it is okay. Okay, this all the gas, it is compressing and expanding. Okay, the gas is compressing and expanding. So certain relations are there. So we'll be able to find out like this. Okay, so this is applicable to only to isothermal process. Okay, if it is adiabatic or if it is slow charging, fast discharging, or slow discharging and fast charging, all those things are different equations already derived and it is available. In internet also it is available. All these equations are available. Most of the manufacturer site also, accumulator manufacturer site also, in Parker or some company, they already elaborately they have given the equations. You can refer. We need not derive like this. Okay. On basic thing you can derive. Remaining you can take that value and so some difference will be there. The other one, n value you have to say 1.2 or 1.3, like that you have to assume, and then a little more exact value you can get. Okay. Even while you are designing now, exact value, that value size accumulator may not be available. You have to go for the next higher size. Okay, little oversizing is to be maybe required to be done, so that you can do. So this is how we find the size of the accumulator.
Now starts.
Okay. So this is the basic equation. Okay, accumulator charging and discharging under isothermal condition. So accumulator volume required is equal to V1 minus V2. Okay, this you can, as per the requirement, you can select what is V1 minus V2. Okay, whether entire cylinder has to be supplied by the accumulator. Okay, or some percentage it has to be supplied by the accumulator. In the design time, initially you will get that value. Okay, in the system analysis, they will say this much percentage accumulator has to supply. So V1 minus V2 equal to pi d square by 4 into S. That percentage you write, that much will be the V1 minus V2. Okay, divided by this pressure ratios, you can apply and you can get the volume of the accumulator. Actually, accumulator charging and discharging under adiabatic condition, it will be like this. So it is some difference is there. So the accumulator volume will be equal to V0 equal to V1 minus V2 divided by P0 by P1 to the raised to the power of 1 by n minus P0 by P2 to the power of 1 by n. So this is the equation you have to use. So here n value you have to assume. According to the, say, you can find out from nitrogen gas and that how much will be the n value. Okay, typically maybe around 1.2 to 1.3, somewhere it will come. So that we can select. So under the very fast charging and fast discharging. So that time we have to use, but generally it is not used. See, fast charging, fast discharging is not used because like chilling effect will be there. When very fast charging, discharging, okay. So the accumulator inside, chilling, the cooling effect will be there. So the elastomeric material get affected. Okay, so this is not generally not used. Adiabatic not used. Okay, so we may use accumulator slow charging, quick discharging, or quick charging and slow discharging. That type of equations, or conditions we may use. Okay, so whatever I explained earlier was a slow discharge, okay, and quick charging. That's why that throttle check valve was connected accordingly. So this is so some changes will be there in the equation. Okay. Okay, dear students. Okay, so we are completing the accumulator also. If you have any doubt, okay, on the pressure control valves or accumulator or any other topic also, if you have any doubt, you can ask. So after that, I am going to talk about maintenance of hydraulic system.
We completed, almost all completed.
Okay.
Then no preventive. Then we'll do
Okay.
video, sir.
Okay.
Any doubts? Shall we proceed for maintenance? No response.
Yes, ma'am.
Okay.
Okay. Others are present or what? Nobody's voice is hearing?
Yes, ma'am.
Okay, okay. All are present? Shall we take the attendance?
Yes, ma'am.
Okay,
Yes, ma'am,
okay.
you can take.
Take the attendance. also,
Okay.
sir.
Okay.
Sir,
Yes, yes. Something you are telling?
can you explain me about
Your voice is breaking.
Can you please ask your question once more, sir? It was not audible.
Sir, your voice is not audible.
Someone
Am I
asked a
audible, ma'am?
question. Can you please repeat
Yeah.
that?
Somebody
Yeah.
asked the question.
Yes, yes, yes. Yeah, please tell me.
I want to know about the function of bleed valve, how it actually functions.
Which valve?
Bleed valve.
Bleed valve. You are connected with accumulator?
No, sir, it is out of contest. I'm talking about it.
Now, what is the purpose of that valve?
Like, for an example, during start of a gas turbine,
Gas turbine.
sir, some of the air which is
Okay. I understood.
Trapped, sir.
So in the hydraulic system, no, air is also contamination in hydraulic system. Question there.
Like, no, the answer to that.
No problem.
Okay.
Yeah. So in the hydraulic system, air is also a contamination. Okay. So there will be some amount of air will be there. Maybe up to 10% air will be entrapped in the hydraulic oil. Okay. But large bubbles, large bubbles create problem. Okay. If it is a very less than 1 mm or something, very small air bubbles will be mixed with oil and it will be moving. But the larger this one, that will get can be removed, maybe get collected at the top of the some component, like cylinder. Okay, the cylinder, that air will be collected to some little bleed valve will be there, and there it gets collected there. Okay, so at a periodically, you can open that that one, okay, tap, and that air can be released. Okay.
Is it
That
clear?
one you are asking, that air, trapped air, that is how to remove.
No, sir. No, sir. It is not the trapped air.
Not that.
Actually, what
In
actually
hydraulics,
happened?
that one only, there are only air bleed valve, we bleed. Bleed port will be there. That one screw or something, little open, that air will escape. Again, it can be closed.
Actually, is there any sample valve with you in your institute?
Sample valve, not there. Sample valve is not there. It is not connected with the cylinder in the hydraulic.
No.
Not hydraulic.
Actually, I think it is not hydraulic. I think.
Then it will be a little difficult. In hydraulic, this is the bleed port will be there. Bleed valve, inside one valve will be there. So air will be getting collected there. So when that can be opened. Okay. Periodically, that is the one process we are doing in the hydraulic system to remove the air. Okay. In the topmost part, that bleed will be kept. Bleed port will be there. Suppose any installations, vertically installed cylinder, that topmost part there will be a bleed port, or horizontally, somewhere it will be there. So that you have to open. So that can be air can be removed. Okay.
Okay.
It may be something else. Okay. Let me see after a time. In that figure is with me, hydraulic cylinder, bleed port. Okay, but I don't remember where it is.
Sir, if you have it, I want to see it.
I'll see, because now searching will be a little difficult. I will give to the madam, okay, and I will send to you.
Sure, sir.
Okay, so that is connected with the hydraulic. Okay, okay, so that bleed valve it is there, so that will remove the air from the system. Okay, or air gets collected, that gets dissipated afterwards.
And sir, in the previous PPT, what actually this 20% volume is will be supplied by
20% means, say when you are.
for example.
So you want to use the accumulator in your system. Okay, probably maybe to downsize your pump. Okay, suppose a pump is a VD of 10 cc you are using. Okay, his cost will be more. Okay, and you are using some operation which is between one operation to the next operation. There is some gap is there, not a very high frequency operation. Okay, there is a okay. So this is a place where we can think of using an accumulator. Okay, so when you use an accumulator, there is a little idle period is there, that accumulator gets charged. Okay, so otherwise unnecessarily energy will go to through relief valve, it will go to the tank. Okay, so energy lost. So we can save that energy and we can utilize for the next time. Next operation we can utilize. So you, instead of 10 cc pump you are buying, you can have a 8 cc pump. Okay, the size of the pump can be reduced. Okay,
It is
your
more
cost will reduce.
advantageous. Sir, it will be
Advantage is
more
your cost will
advantageous.
advantage is your cost is your cost will reduce.
Like what I meant to say is like it is more advantageous when it will be used as a shock absorber, no, sir?
Shock absorber means there is a different application. See, in some application now there will be shock pressures are more frequent, shocks coming in the system. Then you will think of using an accumulator to suppress the shock. But sometimes your operation is not very smooth operation. Okay, there is no shock and all. Then unnecessarily you should not put accumulator there. There is no benefit at that time.
Oh, sir.
Yeah, but it's a horizontally moving cylinder now. When load is hitting your cylinder, okay, some shock suddenly, that type of things comes. Okay, then shock pressure will be developed in the system. Okay, it will act and it will somewhere in the weak point it will break. Okay, if an accumulator is there, that will protect the weak components. It will protect. Okay, so when the shocks are found more in your system, it is better to have an accumulator. There is one type of application for accumulator: shock suppression, pulsation dampening. Okay, you need a smooth operation in the system. Okay, whereas some other type of application is energy storage. You store the energy. Okay, not always all system not required. Okay, suppose we are having 3-4 cylinders. Okay, so one cylinder, all 3-4 are comparable size. Requirements are almost same type. All are requiring 5 liter, 5 liter, 5 liter, 5 liter. Okay, then where is the use of what is the purpose of using accumulator? No use. Okay, whereas see 3 or 5 liter required, and one is requiring 20 liters. Large cylinder. One is a large cylinder. Then the flow rate requirement will be large in your system. Flow rate Q, okay, liters per minute will be large. So when you design the system, you are not thinking of accumulator. Then you have to use a large pump corresponding to 20 liters per minute. You have to the sizing of the pump has to be done. Large pump has to be used. Okay, but the other 3 cylinder now, that time now there are some reserve energy. The large pump you are using, some are some energy unnecessarily going to the tank through the relief valve. Okay, if you use an accumulator instead of 20 liters, you can have a say 15 liters per pump. Okay, so that 15 liter will be supplied by pump. 5 liter should be supplied by accumulator. You have to design like that. What is the size and all? Okay, you have to design. Okay, so that the accumulator will be able to supply that 5 liters. For that, 25% of period of time. Okay, so other 75% of the period it is a little less requirement only there. Okay. But it will supply more, no? Even 5 liter also, pump will give 20 liter only. Okay, is unnecessarily it will go to the 15 liter will go to the tank through the relief valve. Instead of that, use an accumulator and charge the accumulator ready for that 15 liters, or 20 liters requirement. You can supply at that time. Okay, so such type of application only accumulator has to be used. In Ongc also, there may be small operations, number of small operations. Hydraulically it is done. But one large operation is there for a short duration of time. Okay, if you see such circuit, accumulator will be used. If all the actuators are requiring flow the same type of require, or more or less same, then accumulator not required. There is no benefit when you are using accumulator. All your actuators are the same type of requirement. There is no use in using the accumulator. But almost all are small requirement. One is a large requirement. Okay, that time you can use an accumulator. So that you need not design for the maximum flow rate. You can design the system for average flow rate. Understood?
It's a concept of P1 V1 is not clear yet, sir.
The concept of
P1 V1 in accumulator and accumulator.
even see normally in the accumulator when you use okay, before the accumulator is connecting to the your hydraulic system, okay, if it is gas charged accumulator, you have to pre-charge with a certain pressure. Okay, that pressure is called P0. When you are not when you pre-charge the accumulator, okay, then the hydraulic connection is not there. Okay, always we pre-charge accumulator when there is no hydraulic connection. Okay, then it is a what is the meaning of that? The inside gas pressure is maintained to P0 pressure. That is the pre-charge pressure. Okay, suppose your accumulator is there. Okay, you have only a very trickle nitrogen gas. Okay, very small amount of nitrogen gas. Okay, how much energy it can store? If nitrogen volume is not there, it cannot store energy now. Very traces of nitrogen gas. How much energy? It cannot store energy. Some volume of energy nitrogen gas is required to store the energy. Okay, so that we have to pressurize to certain pressure. Minimum some pressure should be there in the hydraulic system. That is the pre-charge pressure. Okay, but how to decide pre-charge pressure? So that is an issue. Okay, so especially those who are new to the system, it will be difficult to understand now. But what is the pre-charge pressure? Okay, so how much you have to set? Okay, whether suppose your system is working at 300 bar. Okay, what should be the pre-charge pressure? Okay, whether it is 5 bar sufficient or 50 bar sufficient or 100 bar sufficient. So what is the pre-charge pressure? So we have to decide. So in the design time itself, we can decide what is the pre-charge pressure. Okay. So one thing is, the maximum system pressure. Yeah, you decided 300 bar. There is a maximum system pressure. Okay. So 300 bar is a P2. The maximum system pressure is now P2. Okay. So that now we call it as P2. Otherwise, you have only P setting. Pressure set maximum set pressure. Suppose accumulator is not there, only that pressure only we refer to. That is the maximum system pressure. What is the okay? But when you use accumulator, already pre-charge pressure has come P0. Okay, and when maximum pressure is called P2. Okay, and corresponding when P2 pressure is applied, hydraulic oil applying that 300 bar to your nitrogen gas, that pressure also will be equal to 300 bar. Okay, so as gas also having the same pressure P2. When hydraulic pressure is P2, in the gas pressure also will be P2. Okay, P0 is connected with only gas, nitrogen gas. Okay, it has no connection with the hydraulic side. P0 is only the nitrogen gas pre-charge pressure. But now you are connecting the accumulator to the hydraulic system. The system pressure is whatever pressure is there. That pressure is being acted upon by the this one accumulator. Okay. So when P2 pressure is there, hydraulic pressure is there, the gas pressure also will be P2. Correspondingly, some volume will be there. V2 will be the volume. Okay, that volume will be very less, minimum volume only will get. When P2 pressure is there, highest pressure P2, your volume will be minimum V2. Okay. Now when the accumulator is supplying the energy to your cylinder, okay, either it can bring back to the P0 pressure, okay, the gas pressure will become P0 and the complete oil is going to cylinder. That way you can make, okay, but sometimes it may not be appropriate to make like that. Okay, there should be always some pressure little higher than the P0 should be there. Okay, when the P2 towards P0 it is coming, okay, we won't allow that to reach to P0. Somewhere in between, by that time the energy supply should be completed. So that pressure is P1. That is an assumed value. The design time we assume it.
Disturbance, sir. There is a disturbance.
Is it?
No, ma'am. No, sir, it is not clear. No.
Okay. So you can see the figures, the three positions you can see here. This is a P-chart pressure, P0, and what volume we have is a V0. This is a P0 pressure and V0 is the volume available.
Is it audible?
Yes.
Okay,
No
okay.
problem, na?
No, ma'am.
Clear?
No, clear, sir.
Okay. So V0 is the size of the accumulator. That's why that is important. The V0 value is important because that is the volume of your accumulator. Okay. So that's why V0 see size. What is the size of the accumulator? We find the V0 value. That's why it is there. P0 is the how much pressure you use to precharge the gas. That's why that is also important. Okay. Next.
Again, there is a disturbance.
See, sir.
Okay.
Yeah.
Okay.
Is it audible now? Is it clear?
Yes, yes, yes.
Okay. Okay. So I think there is no problem with understanding the terms P0 V0. Okay, that we are deciding. Okay, P0 and V0 will be we are going to find out V0 for ultimately we have to find out what is the size of the accumulator. So what is V0? But this P2 V2 is the maximum pressure and the corresponding volume of the accumulator. Okay, so the P2 is the maximum system pressure. That also already in the design. Now, first we are going to find out that one P2. Okay, so that is also not difficult to get. Okay, so these values are clear. I think P0 V0 and the P2 V2 there is no difficulty in understanding. I hope. Okay. Now the problem is why it is P1 V1. Okay, we would have brought back to P0 V0 condition. That is the one thing. Okay, when it is expanding, when the gas is expanding, or when the accumulator is supplying the oil to the system, the pressure will drop here, the volume will increase. Okay, so volume increasing, it will come to back to the V0. Okay, after that it is not able to supply the oil to the system. So we will not bring to that full extent. Okay, we will keep in somewhere in between. Okay, that pressure now P2 we bring it to say suppose 100 bar is there, we can bring it to 95 or we can bring it to 90 or we can bring it to 85. Okay, that pressure is called the minimum system pressure. Okay, so definitely suppose 100 bar is there, 100 bar to 95 when you bring, okay, but the volume change will be small. Okay, but that volume should be equal to what volume you have to supply to cylinder. Okay, so you have to increase the size of the accumulator. When P1 value is more, okay, the size of the accumulator will increase. Okay, so in the equation you see, okay, in the board we have seen the equation V0 equal to V1 minus V2 divided by P0 by P1. Okay, so that P1 will affect the size of the accumulator. Suppose 100 to 95 bar now is the minimum system pressure. If you decide, okay, what size of the accumulator required will be more. Okay, if you take it to 90, 100 to 90, okay, you get more volume here. So that much volume, can fit into the cylinder requirement. Okay, so the size will reduce. Okay, so you can reduce the size if you have a large difference. Okay, a small difference is there. See, 100, 99. Within that, it should supply the required volume to the cylinder. The size of the accumulator should be more. It affects the sizing of the cylinder. So design we just take in bit somewhere 10% less. Okay, and we can see that. Okay, how it is sizing is coming. Okay, so suppose 100 is there, you selected 90 bar as the P1 value. Okay, then what will be the pre-charge pressure? The pre-charge pressure will be 90 into say 90% of the minimum system pressure. Okay, that's why this minimum system pressure is important. We take the percentage on the minimum system pressure. So minimum system pressure is 90 bar. Okay, so 80 to 90% we have to take for energy storage applications. Suppose you take 90%. So 90% into 90 bar. So 81 bar. The pre-charge pressure should be 81 bar. So that should be the pre-charge pressure. Okay, that is how we calculate the pre-charge pressure. So system pressure you are going to get first. Assume some minimum system pressure. Okay, and then some percentage of that pressure will be the pre-charge pressure. That is how the design process we take it like that. Okay, clear?
Sir, in every application, it has to set up or what, sir?
No, we need P1 we need not set. And automatically it will take care. So you are going to set P2, your system pressure, by relief valve. That is what is P2. Okay. When you pre-charge, accumulator, you pre-charge with the P0. Okay. P1 is automatically somewhere it will reduce and it will start increasing again. As per your design. As per your design, it will take place. You need not, the operator or anybody will not be aware of that. It will be in between. Okay. But because of that value only, you got some size of the accumulator. Correct? Because you selected P1 and based on P1 you got P0 and based on that you got V0. Okay. How you got the size? Because of the assumption of P1. Because you have of your assumption of P1, you got the size of the accumulator. Clear? The size of the accumulator is equal to V1 minus V2 divided by P0 by P1. Okay. So because of this assumption, some size will come. Okay.
Okay, sir.
That's how. Okay. This is only design. Afterwards, when you put into use, nobody will come to know about that. Only designer will know what value he assumed, for P1. Okay. So generally we won't see that. So very commonly we say pre-charge pressure in the accumulator. Only we say pre-charge pressure. As far as accumulator is concerned, we say pre-charge pressure. Okay. We have to charge to that pressure. That's why that is important. Once you purchase, volume is also fixed. Afterwards, you cannot change the volume once you purchase. Okay. So, but the pre-charge pressure you have to remember frequently because the charge will get relieved. Gas will leak. Okay, maybe 1 year, 2 year, pressure will change. Pre-charge pressure. Again, you see the pressure and again you have to pre-charge. When it is reducing, again you have to pre-charge to the required pressure. So pre-charge pressure is always required. Okay, probably in the drawing it will be given. Okay, what is the accumulator nearby? That pre-charge pressure will be written. To that pressure you have to pre-charge accumulator. So periodic maintenance activity, you check the pre-charge. Okay, if it is 80 bar required, only 75 bar is there. You have to again pre-charge. Okay, you have to again. So pre-charge kit will be there. Okay, pre-charging kit available. So with that nitrogen cylinder and pre-charge charging kit, using that you have to pre-charge with the nitrogen gas to the required pressure. So pre-charge pressure is always important in the application. When you are operator or maintenance technician, maintenance engineer, this is important. Okay, what is the pre-charge pressure? Now when the gas is reducing now, the ability to store more energy will be reduced. Less gas, less amount of energy only it can store. More gas is there, more energy it can store. Okay. So if the gas is leaking, then again you have to pre-charge. Okay. Again charge the accumulator to the pre-charge value that is required. System pressure will be written in everywhere, in your circuit, gauge, everywhere, relief valve.
There is a disturbance, sir. No, sir, it is a disturbance. Disturbance is still there. No. No, sir. No, sir. There's a lot of disturbance.
How about now? Is it clear?
Sir.
Sir, clear, sir, clear.
There, no? Okay, okay. So you may be a maintenance engineer or operating type of work you are doing in the ONGC, machine operating. Okay. Then normally you have to interpret the circuit. Circuit diagram will be there. Interpret the circuit. Okay. Suppose any decision you have to take. Something is not working. Which component is not working? Okay. Or a maintenance engineer. Okay. So you have to interpret the drawing. Okay, that you must be able to know that. Okay, there will be so many symbols used, and various say ONGC may use a particular way of representing the components. Okay, based on from where you are buying, accordingly it will be there. You must be able to understand. Normally ISO symbols are used. ISO 1219. That is the symbols as per ISO 1219 we are using. Okay, if it is some other symbols, industry standard symbols, sometimes it may be a little difficulty. But once you understand the basic symbols as per ISO 1219, even other standard also not difficult to understand. Nowadays, almost a similar type. Even ANSI standard, if you think, almost similar. There is not much difference. So it will be easy to interpret your circuit, how the circuit is working. Okay, maybe you have to trace the circuit from the pump to the actuator. Okay, you can take a pencil and you can trace, because it will not be straight like what we draw in the fluid sim. It will be, your pump may be page 1. Okay, your valve will be page 6. Okay, cylinder will be page 10. Okay, different pages it will be there. So how you trace? Okay, or even if everything is in one page also, it will not be straightforward. It will be so many lines, vertical, horizontal, vertical, so many lines. So you can trace how it is going. Okay, from the pump to your actuator. So in between you will find various components. Okay, so like check valve, there will be filters, there will be relief valves. Okay, so many components will be there. Pressure reducing valves, then directional control valves. Directional control valves also may be little more complicated looking, like you may find. Okay, but it is all like 4x2, 4x3 or like that only. Okay, you may have a number of positions. Sometimes 4x8, 4x6, like that position also may be there. Okay, then it is from the valve it is going to the cylinder. Maybe in between you have got a throttle valve or a counterbalance valve or a sequence valve. This type of things will be there in between. Then the cylinders, okay, cylinders, motors, all those things will be there. So that tracing, if you do, okay, you will be able to understand the circuit. So basic thing is like this only. What we taught, as per that only basic. And more practically, when you do the more in the industry, you are in the industry, okay, it will be more complicated, little more complicated. It may look like complicated, but it is not very complicated. It is when you trace, it will be easy for you to understand how it is working. Okay, so what pressure it is working, all will be marked on the drawing. If you are able to interpret that, okay, any circuit you will be able to interpret. If one circuit, if you are able to interpret, any circuit comes also, you will be able to interpret. Okay, that is one thing. Okay, other side, if you are a designer, you are a new, designing a new system. That time you need more, information, more data required, more mathematics involved. Okay, so that time it is a little more complicated in design. Okay, I think you may not go to that level unless you some new thing you are interested to design something which is operated with the hydraulics system is there. Then it is a design is required. Otherwise, normal is a component. What is the function? What is the input? What is the output? Like the relation. So pump, then valve, then the actuator. This is how it is going. Okay, you may have number of actuators, not only one. Maybe number of actuators will be there. So various every operation now one cylinder will be there, or motor will be there. Hydraulic motor will be there. So that way you must be able to interpret circuit and how the system is working. Overall, how the system is working, if you know, it will be very easy to understand. Okay, and then identify the component. Say 4x2 valve. Where is the component on the machine? Okay, or relief valve. This is a relief valve. You must be able to identify the component. Okay, troubleshooting. Okay, now we are coming to that topic only. Okay, maintenance and troubleshooting. Okay, we'll discuss various aspects of maintenance and troubleshooting now. Shall we break some 5 minutes and then we start maintenance and troubleshooting?
Shall we take a small break for 10 minutes?
Okay, sir.
Is it audible? Welcome back again to the afternoon session. Is it audible?
Yes, ma'am.
Hello? Okay.
Yes, ma'am. Yes, ma'am.
Yeah. So we'll continue now. Okay. So next is the maintenance of hydraulic systems. We have to share, I think. That's it.
1 minute.
Okay.
Okay.
So maintenance of hydraulic system. Okay. So first a small definition we can give. Okay. So maintenance covers a broad range of routine maintenance activities or repair activities intended to keep the system in a satisfactory working condition at all times. So that is the definition you can give for maintenance. Okay. So we carry out various activities. Maybe servicing activity, there will be a visual inspection. Okay. Where maybe an examination. Okay. Or even up to the overhauling. Okay. All these are maintenance activities. Various activities we carry out. For doing a successful maintenance or repair activities, hydraulic technicians should have the knowledge of physical laws of hydraulics. Suppose you are a hydraulic maintenance engineer, okay? You should know the some physical laws of hydraulics, like Pascal law, what is viscosity, okay? So certain terms you should know, okay? The knowledge of functions of symbols of components. What are the components used? What are the symbols for that? Necessary maintenance and troubleshooting skills. The technician should take adequate safeguards to prevent personal injury and damage to machine. The most important thing in the maintenance is that you should take all precautions to prevent the injury. Okay, there will be hazardous operations. Okay, so you have to wear the PPTs. You have to various precautions you have to take. Okay, should have the knowledge of things where the hazards are involved. Okay, and where the PPTs. Okay, so many things are there. The safety issues. Okay, so that you have to take care. So maintenance can be classified as preventive maintenance and corrective maintenance. Okay, I think these are all preventive maintenance and corrective maintenance. Preventive maintenance is that before any fault occurs, you take various actions, okay, to prevent the fault. Okay, these are the preventive maintenance activities. Okay, so in the case of hydraulics, you install filters, you maintain the filters. Okay, you check, you visual inspection you carry out daily basis. You carry out the visual inspection. Okay, all these are preventive maintenance activities. Okay, but after the fault has occurred, okay, naturally after some time the fault will occur. Okay, however you do the preventive maintenance, sometimes the fault will occur. Okay, so then whatever activities you carry out after that, it is called corrective maintenance. Okay, or troubleshooting. You will do the troubleshooting. Okay, after the fault has occurred. Before that, it is a preventive maintenance. Maintenance involves a closely related activities. What are all the activities generally involved? One is the inspection. So inspection involves careful observation, scrutiny of the machine without dismantling it. Okay, this is nothing but visual inspection. You just watch. Okay, you see the gauge. Okay, whether pressure dropped, or you see some cylinder rod is bent. This is a visual inspection. Okay, some oil is leaking, so it's a visual inspection. Okay, it includes visual and operational check. You switch on, switch off. Okay, operational check you carry out. This is the inspection. Okay. Then servicing activities. Servicing refers to the cleaning, adjustment, lubrication, and other maintenance functions without dismantling the machine. Okay, you clean every day. You are cleaning the surface and all. Okay, this is a servicing activity. Say suppose lubrication problem like pneumatic, some lubricant required. You lubricant in the level is down. You have to again replenish the lubricant. Okay, like that. Okay, if the pump is there, any lubricating oil, any requirement, machine, some machines lubricant, minimum lubricant required. So you can, if it is not there, you you add more. That is a servicing activity. Then examination. Okay, examination relates to the inspection without necessary dismantling, with the necessary dismantling, measurement, non-destructive test. Okay, to obtain useful information regarding the condition of the components or sub-assemblies. Examination means you carry out some test, or you open some part of the system, okay, and then you check some component, okay, probably some fault has occurred, and then you carry out the examination and find the faulty component. This is normally to find out the faulty component, okay. So this is examination, okay, and then the overhaul. Overhaul means refers to the extensive work done with the objective of repairing or replacing worn out or defective parts. The machine is dismantled partly or wholly. Parts worn beyond acceptable limit are replaced, followed by functional checks and measurements. That means overhaul, if you do, when you will do the overhaul, when the machine fails many times, okay, and then you feel that now we have to do an overhaul, complete checkup, full checkup, okay, you open the complete machine, you check each and every component, what is the condition of the component, and if it is required to be replaced, that component can be replaced, okay, and then you assemble it, the machine, and then again you carry out, you check and test, and whether it is okay or not, okay, then again you can use the machine. That is overhaul. So these are all maintenance activities: inspection, servicing, examination, and overhaul. What are the requirements of preventive maintenance? First thing is to know the machine. Okay, if you know the machine, okay, you will be more confident to go and operate or carry out the maintenance work. If you don't know anything, you will be afraid. Okay, so first thing is to know the machine. Okay, then understand and follow the best maintenance practice. So here in your organization, there will be some maintenance procedures specified. Okay, best maintenance so practices are there in your organization. You follow that. Okay, there will be some document or literature available. You read that and how the machine should be maintained, so that you follow that. Okay, follow the instruction manual, compile maintenance checklist. What are the maintenance activities to be carried out? You can compile a checklist. Okay, so daily maintenance or a weekly maintenance or a monthly maintenance. What are all maintenance activities to be carried out? Okay, periodically, no. So that will be compiled in a checklist, and as per checklist, you can go and check. Okay, that is a compile the maintenance checklist. Okay, next, ensure the safety. So when you carry out a maintenance activity, all safety precautions to be taken to prevent injury or the damage to the property. Stock essential spares. It is better to always have some essential spares stocked, so that any fault occurs, any component is gone out of order, immediately those things can be replaced immediately. If it is a frequently, suppose something frequently it is creating fault. Okay, those spare part you can keep. Okay, so these are the requirements of preventive maintenance. Now the hydraulic system. Okay, what are the preventive maintenance of hydraulic system? Okay, main thing you can.
Voice is clear.
There is a disturbance.
Okay.
Drink tea, sir.
Oh, no. So you can see one hydraulic system. Okay, so we'll try to extract maximum information regarding maintenance here. So the tank is there. In tank is filled with oil to a certain level. Okay, there will be some minimum maximum level marked in the level gauge, you know. So within that it should be there. Okay, then there is a so many things here inside. Okay, there is a suction pipe. Okay, there is a pump is here. There is a coupled motor, electric motor. The pump, then the system. Now this may be like a filter or something like that, or I think check valve. It's like a check valve. Then there is a directional control valve. There is accumulator. There is a cylinder, and there is a hydraulic motor. Okay. Then the return line you will find one filter, and it is returning. Okay. This oil is going through the system. Okay, through the pipes and all, it goes to every part of the system. The oil is going and coming back. Oil is continuously circulating through the system. Okay, so it has been found out that 70 to 80% of the hydraulic problems are due to the bad quality of the oil. Okay, due to oil. Oil is the main is responsible for most of the hydraulic system problems. Okay, so if you concentrate on hydraulic oil, most of the problems can be eliminated. So here you can see hydraulic oil contains various contaminants, solid contaminants. Okay, it may contain water, it may contain more amount of air bubbles. Okay, and also various other contaminants like some wear metals. So many things will be there. Okay, there will be oxidation byproducts. Okay, oil will get oxidized. If it is favorable conditions are there, oil is getting oxidized. And see, oil is means what actually? Normally, hydraulic oil is a mixture of some base oil and certain additives. Oil is not a very simple oil. It consists of one base stock plus additives. Okay, additives can be up to 25%. So that means there are many various chemicals involved in the hydraulic oil. Okay, your base oil may be petroleum oil. There may be synthetic oil, there may be vegetable oil. These are all hydraulic base oil. Okay, and then we have the additives. Okay, various types of additives like oxidation inhibitor or extreme pressure additives, anti-wear additives. Lot of additives are there. These are nothing but chemicals. Okay, so now in the oil there is also possibility of water entering. Okay, through some opening will be there. Okay, there will be some opening. Okay, there will be one breather. Okay, I am not able to find here. There will be one breather will be there. One filter will be there. Okay, with the desiccant material, filter material and desiccant like silica gel. Okay, the filter material will remove the solid particles and desiccant material will remove the moisture. Okay, so that will be filtered out and it will be the clean air will be in contact with the fluid surface. Okay, but there is a chance that little moisture still will be there. Moisture will condense when, suppose night time when you are not working, when the temperature is cooling. Okay, then the moisture will condense and it will enter into your oil. So there will be possibility of various contaminants entering through that way. So there will be solid contaminants, there will be moisture, there will be air. And there will be, when the system is working, there will be heat development. Oil will be heated up. Okay, when the more oil is going through relief valve, okay, so whatever work done by the relief valve will be converted into heat. That heat will be transferred to the oil. So progressively, the temperature will increase. Okay, it will go and approach to your system temperature. There is something called a system temperature, maybe 65 degrees centigrade or 70 degrees centigrade. Okay, that may be your system temperature. Okay, that means oil is hot. There is moisture, there is air. Okay, in that moisture and air there is oxygen. Okay, oxygen and heat, that will cause the oxidation. That will be okay, and your chemical, that will be oxidized. The oxygen will react with the chemicals. It will form some other compounds like varnish, acid, sludge, okay, resins. So many things will be formed as a reaction products. The reaction products will be formed here. Okay, more dangerous is acids. Okay, acid will again react with your component surfaces and all. Okay, it will cause the corrosion of the components. So many problems will be there. So what we have to do is to prevent all those things being taking place. Okay, we should prevent the oxidation being taking place. Okay, natural oxidation will be there. Naturally, your system will oxidize. Maybe 1 year, 2 year, 3 year, it will oxidize. Okay, but we don't want the oil getting oxidized in 1 month or 2 months or 3 months. Okay, so that should be prevented. So you have to prevent heat should be maintained within the system temperature. The filtration should be there. Solid contaminants should be filtered out, and all the moisturization, moisture and all, should be kept within the limit. Okay, some amount of moisture will be there, like 100 ppm, 100 parts per million. Up to that, you can have the moisture. More than that, definitely your oxidation rate will be going up. Chemical reaction will take place, and reaction product will be there. Your oil will change into something else. Okay, acid will be formed, and even his quality will change. His color, odor, everything will change. Okay, so in the maintenance, we have to see, okay, what is how much oxidation has taken place. Okay, so normally we send the oil to the laboratory, for testing. So that time we can find out. Okay, or suppose if an experienced maintenance person is there, you will see the color and smell, odor you will see, and you will be able to say the oil is fully oxidized, reaction has taken place. Now we cannot use it. We have to replace it. Okay. After some time, some stage will come like that. So by seeing the color and odor, we can decide, or you can also decide by periodically sending the oil to the laboratory, and the test result we must interpret, and we can decide something. Okay, that is, we can say proactive maintenance. We have to do some proactive maintenance by collecting the samples of the oil and sending to the laboratory, and then interpreting and taking action. Okay, after that you have to action should be taken. What are the corrective action? Okay, so that is one thing. Okay, so contaminants, then the water and air and all will create problem. So maintenance person should prevent that from being more oil, air entering, more water entering. All those things we should prevent. Okay, so we are keeping filters and all. At various places we are keeping filters. Suction side one filter will be there, or strainer will be there, or pressure line filter will be there, or return line filter will be there, like that. That filter should be maintained properly. Okay, just keeping filter not sufficient. You have to maintain. When it is clogged, you have to replace it. Okay, the filter element can be replaced. So all this activity you have to carry out when this one. Okay, when you are maintaining hydraulic system. So you have to concentrate on the oil first. Okay, and also the level of oil. See, afterwards, it's leaked. Okay, every time oil is leaking, the level will come down. So when it goes down to certain level, okay, so your gap will increase. Say pump and pump central line and this gap increases. What will happen? The vacuum pressure will be more. The vacuum will be more than what you designed. Okay, we don't want more vacuum in hydraulic system. It should be within certain limit, like minus 0.1 to minus 0.35 bar. That is the pressure normally we keep at the suction side. If it is more height is there from oil level. Okay, when oil level come down, now the height will be increasing. Okay, from the oil level to the center of the pump. Okay, then the more vacuum will be there. If the vacuum goes below the vapor pressure, the oil will turn into vapor. Okay, so again when it is pumped, pressure increases and the vapor will break or collapse, and then what is known as cavitation will take place. Cavitation taken, not taken. So I think you will be knowing cavitation. So there will be cavitation. Okay, so in the system, so that cavitation is a very destructive process in hydraulic system. So means the bubble will implode. Okay, the vapor bubble will be formed. When the pressure again increases, it will implode, and a very high pressure will be developed. Due to the implosion, very momentarily high pressure will be developed, and that pressure is capable of chipping out the metal particles from the surface of the pump or wherever a cavitation taking place. Even it can take place inside the valve also. Anywhere it can take place. Wherever restrictions are there, there is a possibility of cavitation. Okay, when cavitation is there, there will be production of generation of wear metals. Lot of wear metal will be produced. So that wear metal will again, that will be traveling at certain speed. Again, it will chip out other particle parts. Okay, and then more and more wear metal will be generated. So all will create problem in the very delicate component like valve, cylinder, and all. Now there will be some critical clearance. It is with that it is meant. It is designed and it is manufactured. Okay, typically some 10 micron, okay, or 25 micron or like that. Level it will be. The clearance will be there. So this bare metal and all, it will create problem if it is trapped in between the moving parts, and it is trapped there continuously. It is moving forward and return back. Okay, in that more and more wear scratches will be made to the internal surfaces. Surface degradation will take place. Okay, that should be prevented. So oil level. So oil level should be maintained within the limit. So there will be usually level gauge will be there. There will be minimum level marked and maximum level marked. So within that, you should maintain the level. So that is what is one thing required. Okay. Then you have to see various components. Okay. And component maintenance will see. Okay. Then what are the things? Contaminated fluid, insufficient fluid, wrong fluid. Okay. That happens especially when you replace the oil. Okay. So the oil should have a certain viscosity. Okay. Suppose you are using 46 grade oil. Okay. Then when you are replacing the oil, only 46 grade oil should be used. Okay. You can use mineral oil. You can use fire resistant type of oil. You can use a synthetic oil. You can use vegetable oil, biodegradable oil. Okay. So when you are replacing the oil, okay, the same type of oil, you should replace with the same type of oil. Okay, what is the original oil? As per same type you should use. You should replace. Otherwise, there will be some issues will come. Suppose 46 grade oil you are using, you replace with the 68 grade. Okay, the thickness will be more, and your energy losses will be more. Okay, or sluggish operation will be there. Lot of issues will be there at that time. Okay, so that is what wrong fluid when you are replacing. Leakage. So you can see that wherever any loose connection is there, some leaking will start. Okay, oil loss will be there, pressure loss will be there. All this will be a problem. Dirty filters. Okay, you have the filters, but you are not maintaining filters, then there is no use. Okay, so whenever the filters are become dirty, usually there will be indicators. Okay, there will be visual indicators or electrical indicators will be there. Okay, when the filter is clogged, then the indication will come. So you visualize, constantly watch those things. Okay, when it is time to replace the filter element, okay, you replace the filter element. Okay, there will be indicators like one sleeve will be moving or some pointer will be there. Okay, so some green range will be there. After that, yellow range will come. It's a warning. Then the red range will come. There is a time to replace the filter. So like that, things will be there. Loose connections. Okay, whenever loose connections are there, it is a dangerous in hydraulic system. You have to check whether there is any loose connections. Then excessive heat development.
Your voice is not clear. Your voice is not clear.
Okay. So now excessive pressure, okay, pressure setting now, some issue in the pressure setting. Okay, somebody has operated pressure relief valve unknowingly. Okay, the more pressure is set, it is a problem. Cavitation is an issue. So these are all the main issues in the hydraulic system. Oil, okay, maintenance of hydraulic fluids. So modern hydraulic systems are stressed and degraded due to the presence of contaminants and severe working conditions. Okay, so usually clean oil will be like a little yellowish, very clean oil. But when it is completely it is contaminated and oxidation reaction has taken place, then the color will change to dark color, blackish. It will become blackish, and the very pungent smell will be there.
Is it clear? Any doubts? Audible? It is audible?
Yes, ma'am, it's audible now.
Okay, so in the hydraulic maintenance, maintenance of hydraulic fluids. Okay, we should know the properties and behavior of the fluids. Okay, what are the different properties like oxidation resistance or is viscosity, lubricity. So many properties are there for hydraulic oils. Okay, so that behavior of the fluids we should know. General maintenance activities, various monitoring activities, fluid handling precautions. Proactive maintenance are there, like filtration, fluid sampling, and fluid analysis. Okay. Then the general maintenance activity for hydraulic system: clean the areas around the reservoirs, filters, piston rods. Say cylinder piston rod is getting extended. Okay, well the piston is extended, more particles will be falling on the road. Okay, so when it is coming back, those particles should not go, should not enter into the cylinder. Okay, or into the hydraulic system. So we have to clean the areas. Okay, clean hoses, tubes, piping during installation. Check pumps, reservoir, cylinders, lines for leaks. Is there any leak anywhere? Check the fluid level in the reservoir. Keep them filled. Okay, filter fluids when filling. Check appearance and smell of the fluids. Okay, generally, this color of the oil will be okay. So initially it will be like this. Later on, when oxidation is not taking place, his color changes. Okay, up to this okay. When it changes to this level color, we have to change the oil. Okay, or when lot of moisture is entered, it will become frothy. Okay, then also you have to change the oil. Take fluid samples regularly. Say the machine, some point will be there to take the oil. Same point you take, always you take the oil from the same point. So you take the sample through this syringe bottle. Okay, you collect some 200 ml or 500 ml oil you can collect. Okay, send the sample to the analysis laboratory will be there. Okay, they will analysis. You can tell what are all you want to check. You can say solid contaminant, like as per ISO standard, ISO 4406. Some standards are there. Okay, so as per that you find the contaminants, send the and then monitor the fluid level. Even you can ask for the viscosity. What is the viscosity of the oil? What is the acid level of the oil? Okay, so various things, parameters are there. Various things you can check. Okay, you can ask the laboratory to measure. Okay, and then they will give the report. Monitor the particulate level in the fluids. Check for excess water content. How much water is there? Okay. So as I told earlier, maximum allowed is 100 ppm, 100 parts per million. Maybe I think it is maybe 0.01% water is allowed. More than that comes, we have to take some action to remove the excess water. Like vacuum dehydration, like that you can take action to pass the oil through the vacuum dehydrator. Then the water can be separated. Clean oil will be coming out. Check the symptoms for oxidation. Is there any oxidation taking place? Any accelerated oxidation? Okay, naturally oxidized, no problem. But very fast rate, oxidation taking place, that we have to find out. Replace fluid with a fluid at appropriate time. Okay, when the time has come, we have to replace the oil. check appearance, smell, monitor particulate level, maintain filters, check excess water content, check oxidation, check excess air, check excess heat. Okay, precautions while handling the fluid. So when you are handling the fluid, okay, do not keep the fluid containers open longer than necessary. Wear gloves impervious to fluids. You have to wear the gloves. Sometimes, some people may get allergic. The fluid may be allergic to some people. So you have to wear the gloves. And sometimes, in starting time may not be problem. Continuous exposure to fluid, it may be a problem. So you can wear the gloves. Then use eye protection when handling fluids. Okay, there will be splash of oil in sometimes. So whenever you are using hydraulic system, or okay, always use the eye protection. Okay, goggles you can wear. Okay, if skin is exposed to oil, wash with soap water. Do not mix the different categories of fluids. Leakaging, oil has gone down. Replenish. Some kind of oil that then.
There is a
That
light
is
disturbance, sir.
okay. Okay, so do not expose mineral-based fluids to high temperature and open flames. Okay, normally mineral-based oils is flammable. Okay, it's fire point and flash point. Now it is low, so you should not do that. Some mineral-based also so that mineral analysis 100 ml center okay this level decay fluid analysis early one component. Suppose some spectrometric what are the
There is again disturbance in your voice, I think.
okay, so analysis of minute metal particles gives an early warning of a potential fault in a component. Okay, so as I was telling now, the spectrometric analysis will reveal now what are the metal particles. Okay, what different types of metal particles included that is found in the sample. Okay, then that is an indication of, say you find some brass particle. Then you can say where is the brass used? Maybe the bushings, some cylinder bushing, there may be some side loads, more side load. So its alignment is disturbed. So there is an indication. Somewhere this type of problems are there. Sampled result must be evaluated for trends that may indicate a likely change in the state of the system. Okay. So you should record. So every time the testing is done, what is the problem, how it has happened, which machine. Okay. So if you have a constant data, your database is there, you can find out why it is some particular machine is failing. Okay. So you can find out what is the reason for that. Okay. Frequency of fluid analysis has to be determined by the nature of application. Okay. What type of application? Very severe application is there. Accordingly, the frequency has to be increased. So sometimes you send the fluid to every week, once in a week you send, or once in a month you can send the fluid to the laboratory, or once in 3 months you can send. That depends upon the severity of application. Okay, very aggressive application is there, very frequently you have to send. So fluid sampling, okay, laboratory, the testing. So how to collect the sample? Okay, there is some process. Okay, so you have to operate the system for some time. So when the system is idle, then you should not take sample. It should be run for some at least half an hour. Okay, the normal condition it should reach. Okay, then you can take the fluid sample from some middle of that. Suppose the oil level is there, middle of the oil level, you can take the sample. Okay, and then always take from the same point. When you're taking from this point, they always take from the same point. Say this time here, next time another place you take. No, that is also not advisable. Insert the syringe to 1/2 of the fluid height. Drain sufficient quantity of the fluid from the first you take and you rinse and you remove. You throw the oil. Okay, you purge the line. Okay, before collecting the sample 2-3 times. Like a washing type. You wash the fluid bottle also, maybe already some contaminant. Again, you collect the oil. Wrong result will come. That's why you take the oil, purge that, and again 2-3 times. Okay. Then the good sample you can collect. Fill the bottle with the fluid, leaving a small volume. Completely should not fill. Little gap should be there. Then tag the sample with the bottle with the pertinent data like machine number, date, fluid supplier, fluid type and all. You can in the tag, you can put a tag, date and all. Which date, which machine. Okay, all those things you can give. Check the filter for clog, filter. Okay, maintenance of filters, regular maintenance of cleaning and replacing. Okay, generally, you cannot clean. Okay, only if it is a strainer, wire mesh. If it is a wire mesh, we can clean. Whereas other type, like paper filters and synthetic filters, you have to throw away. You have to filter element, you have to throw away. You cannot clean it. You have to replace it. When it is clogged, you can replace those type of filters. Only wire mesh, say synthetic, wire mesh. Okay, steel wire mesh. Okay, that you can clean. See the filters condition you see after the, clogging or oxidation, all those things, sludges and all, getting collected. Cleaning, remove the filter element and shake out dust. Rinse with natural solvent. Rub dirt with a brush. Shake.
There is a disturbance again.
somewhere, some small loose contact.
Is it done?
Yeah. So the filters, how to maintain the filter, replacing. Okay. The filter is there. You can open this one. Okay. There are two types of filter. One is the spin-on filter. Okay. Your filter and the housing will be integrated. You cannot separate. So the whole thing you have to replace it. Or in some other design, you can remove the filter housing. Then the filter element will come. That also you can remove. And only the cartridge you can replace. The cartridge that you can replace. Okay. So usually filter clogging indicator like this. So like this. Initially it will be like this. As it gets clogged, the pointer will move like that. Okay. Then it will come to red line, red zone. Okay. That time you have to replace the filter element. Reservoir. Okay. The reservoir is there. Okay. Various maintenance activity you can carry out. Clean the exterior surface to remove the dust, dirt, oil. Examine externally for any signs of rust or corrosion. Paint the corroded areas. Inside you should not paint, only outside. Okay. Inside the painting is not done because if the paint is peeled off and it will travel through your hydraulic system. So paint the corroded areas outside. Clean interior surfaces through access provided. Cleaning, only cleaning interior. Okay. And check fluid level regularly. Prevent the ingress of water, air or other contaminants. Then there is also magnets, we are providing some magnet you can provide inside the reservoir to attract the ferrous metal particles, ferrous particles. It can attract. Very minute ferrous particle also it can attract, which a normal filter cannot catch. Even though those particles also can be attracted by the magnet. So, but once it is fully loaded, you have to remove the magnet and you have to clean it. You have to remove that. Okay. So clean magnets inside frequently. Check for loose inlet pipe on the suction line. See, suction line, little the pipe will come down. Little gap comes, the air will enter inside. There may be more cavitation and all will take place. So check the loose drop tube on the return line also. Inspect the screwed connections for leaks. Tighten loose connections if necessary. So that are the reservoir maintenance. Pump and motor. Check for leaks around the pump and motor seals. Check drive shaft for misalignment and damage. Okay. So after the oil maintenance, so that is a maximum concentration we have to give. Next thing is the loose connection or loose vibration, mounting, looseness of mounting or alignment. Okay. Pump motor is aligned very properly. Okay. After some time, it gets misaligned. So that you have to check. So check the drive shaft for misalignment or damage. Check the wear and improper tensioning of V-belts. Sometimes, the drive, say motor to the pump, it is transmitted through the belts. Okay, so belt you have to check the proper tensioning is there. Verify the pump motor unit for any unusual noise or vibration. Okay, normal noise is there that you will understand. If you are regularly maintaining, regular noise you will be knowing. If any abnormal noise, if you found, so maybe misalignment or something. So the noise is more, vibration is more. So you must take action for that. Reduce cavitation. Walls are manufactured with a tight-fitting, delicate parts. Like there will be wall body, there will be spool. Okay, there will be a lot of seal materials inside. Okay, so these are delicate parts are there. Okay, dirt, rust, sludge can lodge between the mating surfaces. In between a gap, it can go and it can fit there. Okay, afterwards it will not be going out or come back. It will be moving along with that. Contaminants are the reason for sticking or the walls and plugging of small openings. Solenoid coils are affected by vibration, moisture, and corrosion. See, normally when you are replacing seals, for example, okay, it should be clean environment. That is what is shown here. Okay, properly clean environment you have to make. Just like that, very dirty environment you keep the spool. Okay, those particles, that will enter inside. Okay, that's why to avoid that. You can keep a clean paper or something like that mat Over that you can keep. If something is exposed, that also you can cover it with some sheet. You can cover it so that particles should not fall on that. So while servicing, okay, it is essential to know the different parts of the valve, how to assemble it, how to disassemble it. Okay. Okay. If you know how to assemble, then only you should disassemble it. Otherwise, don't do that. Maintain cleanness of the valve and surroundings. Once valve is disassembled, check for worn out, damaged part like valve body, O-rings. See your O-rings, O-rings, seals, plunger seats, spring may be corroded. It may be very weak, become very weak. It may be broken. Okay, so all this we can check. Replace worn out damaged parts. Remove burrs, nicks from the internal parts for smooth operation. Clean disassembled parts before reassembling. Okay, before reassembling, again clean every part. Lubricate parts properly with clean fluid. Assemble and test the valve. After the assembly, again test the valve. Cylinder. Okay, in the cylinder, now the critical parts are seals and rods. Okay, most critical elements in the maintenance point of view. Surface of the piston rod must be kept smooth and clean in order to avoid failure of the rod seals and glands. See what are the seals? The rod, no? So these are the seals. There are various seals are there. This is a wiper seal. There is a pressure seal. Okay, bushing. Okay, again there is a pressure seal. So number of seals will be there. Similarly, piston also seals are there. Okay, so these are delicate parts. Okay, so surface of the piston, say piston now it will extend. Okay, it is exposed to the outside environment, and you are in the operation now some particles are falling on that. Okay, and then when it is coming back, there is a chance that that will enter inside again. So now it is entering your hydraulic system. So that should not take place. Impact forces can also damage the seals. Suppose some impact forces are there in your application, that will also damage the seals. More wear will be there, quick wearing will be there. Other issues of concern are the presence of air, internal and external leaks, operation in harsh environmental conditions. Metals, road scrapers, piston road boots can be, like this road boots you can provide. If a very severe metal particles are falling on the road, you can provide boots so that the particle will fall only on that. Okay, road will be protected. Inside road will be there, that will be protected. So no particle can go inside. So this can be expanded or contracted. There's a boot. It can be locally, you can make with even leather and all. Okay. Presence of air contamination, occurrence of fluid leakage, maintaining extremely viscous fluid medium may cause sluggish or erratic operation of the cylinder. The cylinder may be must be aligned and mounted correctly. Okay, for reducing the side loads. Suppose the load, side loads something, some heavy load is towards downward it is acting, so it may bend. The rod may bend. Okay, minimize the wear of cylinder bushing, prevent bending, breakage of piston rod. Okay, check the piston rod for straightness. Check that for dents and damages on the piston rod due to impact forces. Examine piston rod bearing for roundness. Examine the barrel, piston and rod for nicks, scoring and pitting. Check the cylinder for worn components.
Voice is not clear.
We need movement.
Yeah. So like that, no, so every component, we can maintain. Okay, so there are, some maintenance action will be there. So like here, in the cylinder, the barrel and the seal and the rod is a critical part. So that part you have to concentrate and you have to maintain it. Okay. So like that, now various components are there. Okay, now you are reading that now. I will give that material. I will give to the madam. Okay, because now so many slides are there like that. Okay, simulators. Okay, so you can go through that. Okay, I suggest that you go through the. So whenever you are involved in a maintenance activity, those material you can read and you can what are the essential points you understand. Okay, so that will be better. Otherwise, this will be just like a reading, no? So the same thing will be there. So most of the time, there will be the same type of maintenance activity will be there. Okay. Charging, pre-charging. Okay. So charging of the accumulator. Okay, this is the accumulator. Okay, there is a cylinder with a nitrogen. This is a charge kit. There is a charge kit available. Okay. So now you connect to the this wall chuck. You connect to the accumulator. This also charge kit connected to the cylinder also. Okay. Now there is a bleed valve here. In the bleed, you close the bleed valve. Okay, and then you open the valve here for the charging. Okay, in the accumulator. This charge, the gas valve you open. Okay, it is now ready to receive the gas. Okay. Now you slowly open your nitrogen cylinder, slowly open, and the gas will start now going towards the accumulator. You see the pressure. Suppose 60 bar is there. When 60 bar is reached, you stop. You close here. Okay. By chance it has gone to 62 or something like that. Okay. There is a bleed valve in the charge kit. Slowly open. Then that pressure will be relieved. Again, you make the exact pressure. Okay. After that, you can remove and you can close the accumulator here, totally tightly sealed. Okay, you can close here. So that pressure it will be pre-charged to that pressure. Hose connection. Okay. So this material I'll give that material and so madam can give to you. Okay. Because so many things are there. Even safety also there. Okay, a lot of safety issues are there. Okay, safety issue is concerned hydraulic now. So because the safety issue is more because there is a high pressure system. Hydraulic is a high pressure system, maybe 200 bar, 350 bar, very high pressure system. Okay, but as long as pressure is inside the system, no problem. Okay, when it starts coming out, only problem. So what is the one is the high pressure system? How it will come out? Maybe a loose connection and oil coming out, or some hydraulic pressure is something it is lifting. Suddenly their hose breaks. Okay, the load will suddenly come down. So if anybody below that or nearby, it may get affected, or the property may be damaged, or the personal injury will be there. Okay, so the main issue in hydraulic system is it is a high pressure system. Okay, and another is the trapped energy. Hydraulic system now we are using check valves, and there is a 4x3 valve, all cross center position valves we are using. There will be some places, some parts of the circuit there will be energy trapped. Okay, and the maintenance person not knowing that energy is trapped, if he opens, there will be any fluid injection. That is called pinhole leaks. Very small hole, fluid jet will be coming with a very high speed. Okay, so even it will pierce through our skin or body part. It may go to the other side. That much speed will be there. Okay, so that is the pinhole leaks. So all those type of things we have to avoid. Next is the oil. Oil is maybe hot. So when we are happen to be in contact with hydraulic hot oil, we may get burned. Okay, or sometimes chemically we burn. Chemical burn will be there. Okay, chemical reaction will take place. Okay, or allergic. Now you may be allergic to that oil. So oil is also a problem. So one is the safety issue is the high pressure, because high pressure is there inside the system. It is a dangerous. It's a hazardous system. Okay, anytime oil comes down or with that pressure something is being held. If the pressure suddenly drops, that is a problem. Okay, so that is there. Then pinhole leaks. Any trapped energy, the oil is leaking, or okay, this type of things. Then always we have to wear the safety, PP, personal protective equipment. Okay, you have to, whenever you are working on hydraulic system, wear the PP, especially the goggles or the gloves. Okay, this type of things. Definitely ONGC, definitely you will be using it. Okay, but it is a very important in hydraulic system. Okay, especially the goggles. Okay, that is the first thing. Next is the
Close.
gloves. Okay. Okay. Other things and all, shoes or any apron, this type of things are also there. But in hydraulic, that not that much, very much important. First is the goggles and then the gloves. These are the two important things. Okay. Other things not in the as per your system. Danger, hazard. As per that, you will be wearing it. See, any heavy cylinder and all, when you are lifting now, you have to take the help of some support. Okay. And provide ample space for maintenance. See, when you are installing machine, not in a tight corner. Okay. There is no way to see your, the gauge, or something, some warning given. You are not able to read, that is the problem. So, ample space should be there, ample lighting should be there, good lighting should be there. Okay. Lockout, tag out, you will be knowing. Okay, whenever you carry out maintenance, carry out the lockout and tag out. Okay. Another safety issue is the application. Suppose any clamping application is there. Generally, there is a two-hand safety. Both hands should be engaged. So normally we keep two push buttons. In the control circuit, both push buttons have to be pressed. So that way only it is arranged. So your operators, both hands are engaged. Okay. That type of system should be there for two-hand safety. Otherwise, what he will do, only one push button is there. Other hand, he will adjust the job. His hand may go and it may get cut or it may get injured. Okay, that should be avoided. So this is only a safety issue. Okay. See how the pressure getting released. Okay, so now we will stop here. Okay, if you have any doubt, kindly ask.
Sir, any doubts? Response is not coming.
Last time I have not given any maintenance.
That time, sir,
Sorry.
okay. Left, sir.
Okay.
But I told you to
Okay.
just prepare.
I will give this one.
Okay.
Okay. This material now I will hand over to madam. She will send to you.
Yes, sir. Please send this PPT. It is more important. Most important.
Yeah.
Okay, sir. Okay, sir. Okay, sir. Remaining everything is clear.
Any
Yes,
other
sir.
doubt in the hydraulic side? Any other doubt? Because in a short time now, 4 days. Okay. So we have covered something. Okay, without seeing your face. So we have taken. So with some limitation. Okay. So some issues are there. But I hope you gain some knowledge.
I can turn on the videos.
Okay.
Turn on the videos.
Okay. Okay.
Can you please turn on all of your videos so that we can give send off to our guest faculty? Sir has taken very good class. You also know that from last 2 days continuously speaking is not so easy. And he has taken almost, he covered all the topics with the explanation, with the good PPTs. Okay. I am very thankful to our guest faculty. Actually, you also know getting a guest faculty is very, very difficult in this time, pandemic period. Sir has taken so much risk and he has come so far and he has teached us. I'm very thankful, sir. And please give a good feedback to sir. And can you turn on your videos and you can give some small vote of thanks to sir?
Please respond.
Hi.
Hello, sir.
Hope you enjoyed. Okay. Since 4 days, so time limitation was there. Okay, and then there is a no real practical training. Okay, so but only theoretically and with the simulation software, we could cover some topics. And we cannot see your face now, whether how much you are understanding. That part was not there. So otherwise, now when seeing the face, I can understand now. So you're not understanding or is okay like that now. But here, little problem is there like that. Okay. So in future also, if you face any problem, you can always contact us. Okay. Whatever help we can give, that we can give. Okay.
Anyone else want to speak? Please speak.
Sir, it was a wonderful session.
Okay, nice. Thank you.
We learned so much from you. As we are working in the oil industry, which is mainly dealing with hydraulics.
Yes, yes.
And we will see so many walls.
Yes.
We actually don't know. Actually, we are the new joined GTs. We were not that much exposed to field. Still, we gained the knowledge which you have given to us. It will be more useful in future aspects wherever
Yes,
we will work in wherever the unit we will get
yes.
our post.
Yes, yes. Thank you.
From basics to in very ma'am also explained how to visualize the symbols,
Yes, yes.
how the flow, and you also explained how the pumps, how the hydraulics plays a main role in industries. It is like it is a very less time that we have gained so much, but it is not. The time is very less, and
Yes, yes, yes.
there is a lot of subject in it.
Yes, yes, yes. Actually, hydraulic is a little more difficult than pneumatics. Little more theoretically more involved in hydraulics. So, actually, you should understand what is the viscosity, how it is affecting, temperature is there, how it is affecting, and no. So, like that, very fundamental. If you clear any situation you face in your Ongc, you'll be able to handle that. And symbols and circuit, typical circuit only we can in training centers can give. Your actual practical circuit we cannot give, no. So we give typical circuit, cylinder controlled by 3x2 valve, 4x2 valve, 4x3 valves. Okay, and then when it is your duty to responsibility to apply that knowledge in your workplace. So we lifted you to some say 50% level. Okay. From there now you see, and it will be much more easier to handle your circuits and all. Your rig circuit will be there.
The team, NSTA team also had a good effort. They have visualized all the walls. They have shown very clearly in whatever the way they can do.
Yes, yes, yes.
This COVID pandemic made everything has to get visualized from online. It is very, it's like very, very difficult. Still, they managed, and whatever the knowledge we got from you, we will try to implement here. Thank you so much to Shobha ma'am and you sir, the team which was not there in front of you.
Yeah.
I'm very much thankful to them and you people as
Welcome.
well.
Thank you.
And I hope after this pandemic we will be there in your institute
Yes,
to
yes.
gain some more knowledge, and we can work on the training kit which you have in your institute.
Yes, you are always welcome.
Thank you, sir. Thank you so much.
We have validation at 5 o'clock. That time our RD sir is again joining, and our HOD and AO will give you the feedback. After filling the feedback, the certificate will be produced. So I'll take a small 5 minutes break. I will just give, after again my session will start with our RD sir. Okay? We don't
Okay,
give the session. Please be there in the thing. I will play some videos. So after that, you can see, and the time he is joining, we can end the session. Okay. Now don't end the
okay,
session, please. And the session will be up to 5 o'clock.
okay.
Okay, wish you all the best. All of you,
Thank you.
wish you all the best.
Thank you, sir. Thank you so
Thank you,
much.
sir.
Thank you very much, sir. At least
Okay.
speaking.
Have you look at
There is a disturbance, sir. There is a disturbance.
You are not audible.
Excuse me, is the voice audible now?
Yes, sir. Yes, yes.
Okay, so I will show you how your form looks like, your course completion form, which you need to fill up after, like while the people are sitting here. You need to enter your exact email ID which you've provided to us when you're joining the course, and the name, and all the submissions has to be done. After this, then you have to press the submit button. So when you finish this process, you'll get a mail on your mail ID which you have entered here. So there you'll get your certificate. So please, as soon as you get your certificate, please share it with us, so that we'll know whether you've got the certificate or not. If anyone doesn't get the certificate, or if their name is wrong spelling, something like that, then please let us know. You need to choose your name from one of these. Is it clear what I've told, or is there any confusions?
Yes, sir.
Clear, right?
Yes.
Sir, we have to send certificate or just a intimation that we got certificate?
Share your screen and let us know that you've got the certificate. Okay, who all have got your certificate, please share your screen. And as soon as the people, when they sit here, right, so please turn on your cameras. Everyone, I request you turn on your cameras. Okay, RD sir will be joining, so you have to turn on your cameras.
Okay.
Okay, fine. Okay, we'll be playing few videos now. Okay.
Madam, there is a disturbance.
Welcome back. Can my audio is audible? Is it audible?
Yes, ma'am.
Okay. Now we are left one small topic which is called pump cavitation. For example,
This feedback link will be shared. Feedback Google Form link.
yes sir, yes sir. The link will be shared, sir.
Okay, it will be shared on mail ID, no?
Yes sir, yes sir. I will share in the
Insert on
WhatsApp, sir. WhatsApp.
group.
Okay, okay.
Okay. The cavitation is a formation and collapse of vapor bubbles in the pumped fluid as it passes through the moving the element of a pump. This is the definition of the cavitation. It will form in the when it is the vapors is there on the top of the thing. When it collapses, the bubbles into the pump to the surface. That time it will be damages the surface as well as the whatever the surfaces of the walls or on the hose pipes or on the surface of the any type of different type of cylinders or in the pump. So that's why we have to take care that it should not happen and how we can be reduced for this. So cavitation is the formation and collapse of vapor bubbles in the pump fluid as it is passes through the moving element of the pump. Cavitation occurs when the existing space at the pump inlet is not filled by the fluid. Always a sufficient level of the oil should be always be filled. Otherwise, this type of cavitation will be more. So undetected intermediate pump cavitation will eventually causes the sufficient damage of the pump. So this may damage for the whatever the part which is going to happen in the cavitation. Next. Next slide. Okay. Now the suction pump head, it is the actual pressure at which the fluid experiences at the time of pump inlet. So that time the actual pressure whatever we are having, that the minimum pressure, vapor pressure, this is a suction head pressure. Vapor pressure, it is a minimum pressure needed to prevent the liquid from
Audio problem started again.
There is a disturbance, ma'am. There is disturbance.
Hello. All of you, now we are studied this whatever the hydraulics. Now we go for small introduction for the electropneumatic. Just a sensors and some part of the relays. Just you watch these videos, you'll understand, and later I will explain to you.
What do this automatic packaging machine and this lock have in common? Let's take a look. Huge forces are required to open and close the lock gates. Force is required in two directions. Hydraulic drive is the right solution. The lock gates and the control room are far apart. This means that control signals have to be transmitted over a large distance. But a hydraulic pipe is not suitable for this. Electrical control signals, which travel via electrical cables, are the right solution here. In the case of these complex automatic assembly machines, it is not distance that is the primary argument against pneumatic control of the valves. In this case, it is the many control functions required in order for the entire complex program to execute. Here too, electricity has been selected for signal transmission because it is simply more manageable. And because electricity is a prerequisite for the use of electronic open and closed loop control systems. And it allows the system to be linked to the company's data processing system. In that case, why use pneumatics at all, if electricity is there anyway? Well, pneumatics drives allow linear motion to be achieved much more simply. And fast cylinder speeds can be achieved, resulting in short cycle times. In these examples, the control energy is not the same as the work energy. That is why they are called electropneumatics and electrohydraulics. These are so-called hybrid systems. Let's take a look at the structure of circuits with different types of control. Here we have the manual operation of a directional control valve as a final control element. In the pneumatic control, there is a clear differentiation between the control part, left, and the power part, right. Here the signals are generated and logically associated in the pneumatic control part, and the final control element is pneumatically actuated. In a corresponding electropneumatic control, there are electrical signal elements in the control part. In this case, signal processing is not carried out by a special device, but by connection of the various signal elements in such a way as to produce the function. The directional control valve, or more accurately, the solenoid valve, is now actuated electrically. This type of control part can, of course, also be used to control a hydraulic power part. Then we have an electro-hydraulic control. Now let's take a look at what happens in practice. The elements of the control part are, of course, distributed throughout the entire system. The signal elements, here the push buttons for operation, the sensors, and The solenoid switches on the pneumatic cylinders send electrical signals to the machine controller. From there, the solenoid valves are controlled. So here we have the interface between the electrical signal part and the pneumatic control part. Also in the elevator, these two areas are clearly differentiated. The controls in the elevator and on the door, and the sensors in the shaft which report the position of the elevator, together with the controller, form the electrical control part. The solenoid valve is the interface to the power part, consisting of the power pack, the valve in its function as a final control element, and the hydraulic cylinder. These systems also demonstrate why hybrid systems are used. For the large distances involved in the lock, electrical lines and electrical control energy are of course much more economical than a hydraulic control system. And in the case of complex machines like this automatic assembly machine, it is not only the many control lines and controllers that speak for an electrical control part. The logical association of this huge volume of signals is only feasible with an electronic controller. So here we have a complex example of an electro-pneumatic system. And in the case of the elevator, the power part requires huge forces, which is naturally not the case for the control part. So here too, a hybrid system is the right solution, electro-hydraulics. Yet another advantage of a system with an electrical control part. If electricity is available at the machine anyway, monitoring elements and indicators such as buzzers and lamps can be cheaply and easily integrated. And of course, the power part can be supplemented with electrical drives, such as an electric motor. In electro-hydraulic systems, electricity is also found in the hydraulic power supply part. The hydraulic pump of this power pack is electrically driven. Electricity, we take it for granted. We cannot imagine modern society without it. From the coffee machine to the computer, from the lamp to industrial plant. Nothing works without electricity. But what is electricity? Let's make a comparison. In pneumatics, air is the source of energy. In hydraulics, it's oil. In electricity too, there's an energy source, but it's invisible. It's called electrical current, or more precisely, the electron current. There are three terms that everyone knows that define an electric current: voltage, current, and resistance. Voltage has the symbol V and is measured in volts. A rating plate on all electrical devices indicates with which voltage the device is to be operated. The current has the symbol I and is measured in amperes. The rating plate also indicates how much current a motor consumes. And finally, the resistance has the symbol R and is measured in ohms. This value indicates the resistance with which a load opposes current flow. These three variables are mutually dependent. And this can be expressed with a simple formula. V equals R times I. In other words, voltage is Or more practically, current equals voltage divided by resistance, because normally the voltage is given. And the whole thing has a name, Ohm's law. An experiment to demonstrate. The white lines indicate electrical lines. The voltage V is 24 volts. The lamp has a constant resistance of R, and as we see, a current of 84 milliamperes flows. If we double the resistance by adding a second lamp, the voltage at the source is still 24 volts. But the two loads connected in series have divided the current according to their resistance. So we have 2 times 12 volts. Because the current is also halved, namely to 41 milliamperes, the two lamps do not glow as brightly as the single lamp did. That is the disadvantage of this series circuit.
All of you please switch on your
He's
video.
asking all feedbacks. Whatever the courses we conducted, as previous, he's asking feedback. Later. Tyagi sir. We are shared, sir, first course.
అదే వీళ్ళకు 2000 ఇన్స్ట్రక్టర్స్ కి ఏదో ఆన్లైన్ ప్రోగ్రామ్ అని అన్నారట నిజ్బడ్ కండక్టింగ్ బై నిజ్బడ్ అదేమన్నా డిస్కషన్ అయిందా ఆన్లైన్ బ్లెండెడ్ ప్రో ఓకే ఇప్పుడు ఆర్డి గ్రూప్ లో మన ఇతనేసారి చూడండి అదొకసారి అది మెసేజ్ చూడండి
Water jet cutting,
అది చూసి ఒకసారి మరి
water jet cutting,
కంప్లైంట్స్
Sir. Just to say that this 1,000 things, sir, that is.
Y-axis.
Hello.
Make overseas video minimum and
Yeah.
maximum so that we can see that.
Audible है सब लोग?
हाँ सब
Welcome back to our validation section. Sir, we'll welcoming for our HOO, Mr. Mahendra sir and Kumar Velu sir, section in charge, and our AO. And so please join for the validation and give your feedback, sir.
Hello, is it audible? Can you
It's audible.
Sir.
Yeah. Good evening all. Myself Kumaravel, Deputy Director. Today I have taken one class on this introduction of hydraulics. I hope after that today only I am meeting you all. Hope all of you might have enjoyed this session, 4-day session.
Yes, sir.
For you. And it is a big subject. We try to give in a small capsule of 4 days, not much of practical training. We have got a very excellent practical training. Unfortunately, we could not able to show everything to you. But as far as the hydraulic theory concerned, we have covered everything. This is now valedictory session. We want to take some feedback from you. This feedback will be very much useful for us to correct the next course. Everything is there. Develop the next course. To take the feedback, we have with us our head of the office, Mr. Mahendra. Before he is addressing the valedictory address keynote, can just one of you one by one, or you can give your feedback. You already shared a Google Sheet, so that contains a very minimal information. Now, orally also you can share some of your views about the course. Can you start one by one? Anybody start now? Please come forward. Yeah. You just to introduce yourself. Say a few lines about the course. Hello.
Yes, this is Sai Kumar.
Yeah, tell me.
What I can say is like this training is very useful, but the duration is very short. It is 4 days training, and there was a lot of there is a lot of studies there, but we got a basic idea. Shobha ma'am and Georgie sir taught very well from basics to where we can apply in our industries. Before which we can't use to identify the walls which we generally see in the industries right now. I was enough confident that which type of walls and where it can be useful and where it cannot be. Like, and the remaining session by Joji sir also related to hydraulic pumps and different types of pneumatics and hydraulics, actuators, etc. And the whole training is very useful, but the main issue is like we can't do any practical sessions with our hands, and it is one of the drawback we can say. But the whole team did a great job. Uh, they they did their efforts in making the training very useful. They have shown the training kit in an online mode also, which is very difficult, but somehow we have got some idea. We were very, what we can say is like we didn't join there in STI, before which so many batches used to stay there and learn a lot of experience by doing all the things in their hands. Anyway, it is a good experience, sir. Hope this pandemic ends soon, and we will get a chance to visit there. Thank you so much. I got so much knowledge from your team. Thank you so much, Sobha ma'am, and your team. You did a very wonderful job from your end. It is ultimately we have to deal with the things.
Right, Kumar, thank
Disturbance.
you.
There is a disturbance from your end. I'm not able to listen what you're saying.
Right, Kumar, I could hear your feedback. Tyagi this side.
Yes, sir.
Oh.
Yes.
I share your concern that practical part could not be done because of the limitation of online course. But I assure you, in future you will get a chance to attend other trainings at STL Bengaluru. So don't worry about that aspect. We'll take care of that.
Okay, sir. Thank you so much.
Yes, sir. Yes, sir.
Anybody else?
Thank you, sir.
Next.
Yes.
Who is coming forward? Yeah, please.
Swapnil, are you there?
Next.
Ayush.
Good evening, sir.
Good evening.
Yes, sir.
Good evening.
It was very well designed and very well covered all the which are very useful in field. Since sir, I am working in field, so I could easily correlate the various topics which were covered, like valves, actuators, and the hydraulic circuit, gear pumps, and especially the troubleshooting part. In the last, Joji sir also explained how we can troubleshoot the various problems we encounter in the hydraulic circuit. Hopeful that when I'll go back to the field, uh, I will be able to use this knowledge which I gained here and troubleshoot the problems which I face in the field. Thank you so much, Shobha ma'am and your team.
Thank you.
Okay, thank you. Next.
Hello, sir. Good evening. This is Jitendra Prajapati. And sir, the topic was very well designed, and I'm actually not in the field, but the way you have taught is very much. I can understand the most part of it. How, despite I'm not in the field, and I have confidence that if my posting will happen in the field, and then I will use this knowledge and will uh, will do the maintenance part, wall actuator parts, and all the things that you have taught. So overall, very well. It is a very well taught, but there is only one concern that already Sai Kumar has addressed, that we could not do it by our own hands. So in future maybe we will get a chance. So overall, very well presented and taught. Thank you.
Right. Next.
Rehan? Rehan, can you hear me?
Right. Okay, sir, would you like to say something?
Hey, I want them to say. I'm listening. I want to listen to their feedback.
The guys are not coming out. Very difficult to this forum.
Yeah. Anybody else? Rehan, are you there? Can you listen to me?
Oh, the connection problem or
Okay.
yes.
And about Kevin, Animesh? Any feedback?
Yes. Yes, sir. Most of the things were told by my colleagues Sai Kumar and Jitendra regarding, and also I would like to add upon that software thing. That software actually helped me to learn to stimulate whatever the use of valves they have taught. So that software is what like I want to add on. And also Shobha ma'am, in the holiday also I asked her some doubts and she clarified it. So yes, overall it was a very good session.
Thank you, sir.
Shobha ma'am has shared some videos and some training contents with you. So keep them safe. And some of you will be making a presentation on this topic in the end of our special training module. So you can use that training material for any of presentations. I got your feedback that theoretical knowledge which has been imparted is excellent by the esteemed faculty from NSTI. And due to limitations of online, obviously you could not do hands-on practicals. But I think somehow some of it has been compensated by showing you the videos. I feel that in future we will give you a chance to attend the online trainings, this offline trainings. So it's not the end of the road for you; it's the beginning, and you can keep coming to NSTI for attending other courses. And I'm very much sure that the faculty, the expert faculty from NSTI will always be there to help you in any queries, even if you have in the future. You can always keep the contact number of Shobha ma'am and other faculty. If you have any issue, you can always call them. They will be more than happy to help you out. Kumar sir, would you like to say something?
Now I am handing over the mic to Mr. Mahendran. He will give presentation.
Thank you, sir. Good evening, sir. Thank you, sir. And team from the young batch from Ongc. I am Mahendra, Deputy Director HOO. Here I would like to quote two words. One is hydraulics and pneumatics. They are the practical subjects. They are not theoretical subjects. And I would like to request this team, whenever you are in the field, you are working, you find any difficulty, our faculty's contact number is with you. You can share your difficulty, problem, troubleshooting, and you can get it clarified. Now you are connected with NSTI. Though unfortunately because of Corona you could not come for offline training, but still we are with you always, and our doors are open. So whenever this and you can have a hands-on experience. Second, what I would like to say, or I would like to stress that make your hands black to become an engineer, a small quote. So unless you work with your own hands, so you cannot experience, you cannot enjoy. So third point is troubleshooting, probable causes, that's and all second stage. So first stage, prevention is always better than cure. So especially in hydraulics, if you take care at power pack level, oil level, and the normal, abnormal assessing condition, if you are expert, then I am sure 99% no problem will reach to either DC valve level or the final actuator cylinder level. All these things, it is not overnight you will not become master. It is a years together your experience. But the more and more you should focus on preventive maintenance. And you may find in the field resistance to, towards this word. So your specialization speaks that wherever you find the difficulty with this type of kind of words, then without using this type of words, you should prove with your action. So what all the minimum daily routine activities are there, you should never neglect. If you do not take care of the routine activities, then finally one day a major problem will be accumulated and it will lead to a major breakdown. So you should fix a target goal that the machine should not fall under breakdown. This should be your ultimate goal. When that concept is there, with this approach and attitude, always try to see the basic level, and definitely your equipment, machinery, to the maximum possible, or you can say once after a few years experience, it is possible 100% you can reach to zero breakdown. So that situation is possible practically. You can success in this project. So once again, I would like to thank all you. Very good interaction was there during this session. And my special thanks to Tyagi sir. A lot of pain sir has taken start this program. So he was expecting us, requesting frequently. Then we have taken at first permission and our artists' permission. Then only it has become possible to start these programs. And we look forward for offline classes. Thank you all and wish you all the best.
Thank you. Thank you.
Thank you, Mr. Mahendran. Thank you, Mr. Kumarlal and Shobha.
Thank you so much. Now, to final part, we want to get that feedback. All of you, have you filled up that Google form? All of you?
The link is shared in the WhatsApp.
Yeah, link is shared in the WhatsApp. Or you can share here also, Pradeep. You can share. Okay. Can you just respond? Any of you
Please share your screens once you get your certificate.
The moment you fill up the form, you will get a certificate in your registered book, whatever.
Lot of disturbance, sir.
Yeah. So the link will be alive for another 1 hour. Kindly do it. Any trouble is there, put it in your WhatsApp group. WhatsApp group to rectify it. Thank you.
Okay.
Okay,
Thank you,
Mr.
sir.
Thank you, sir. Okay, we will wind up the.
Thank you so much. Thank you so much.
Next
It is please fill the feedback form.
Okay.
Yeah, sir, next course is in the February, no?
Yeah, I already sent the details to ma'am.
We got that mail. We will meet in the month of February once again.
Yeah.
Before that, any other pneumatics course is there?
I think one more pneumatic course we have to do.
You are planning, huh?
Yeah, one pneumatic course is remaining. Our field. That will, I think we'll do it in the month of March.
What about that welding course, sir?
Welding also we are planning in March.
Yeah.
I'm very thankful to all the participants who has given very quick response whenever we are having any audio or video. Response used to come so nicely. We used to feel very happy so that our energy will be not wasted in the thing. Quickly the response used to come. Very thankful to all the participants who has given us the opportunity to do the online courses. I'm very thankful to Tyagi sir, our HO sir and Kumar Guru sir. So I'm very thankful for our setup, whatever they made. Raju Kannan sir, he has done a very effort and making all the communication side. So I'm very thankful to him also. Thank you to everyone.
One more. Thank you, sir.
Yeah, please.
Regarding that institute name change, I have submitted some of the document here. That is sufficient, no?
Yeah. We have already created a new vendor code for you. We'll be sharing with you.
The name of NSTA.
Yeah.
Okay. Thank you. One more thing is that hereafter don't use that Gmail, sir. Gmail is supposed to, you don't see the Gmail. So we are providing them GOV mail. So that I will share to you. You use that mail ID, sir.
Okay, no problem. Please share that details with me.
Pepplur1 at dgt.gov.in. I will share it.
Yeah.
So communicate with that official mail ID.
No issue.
Thank you, sir. Thank you so much.
Okay, sir.
Thank you so much.
Okay, madam. Thank you so much.
Thank you, sir.
Well done.
This is the course I did the last time. This is the time I take. Now,